Oh, should we have Oscar redo the intro or?
Yeah, let's do
I'll
that.
do a I'll do a quick version of it.
Yeah. And we're up.
All right.
I still don't see the screen.
I do.
Can we get maybe two more confirmations and then we'll kick it off?
It's not working for me.
Still says waiting over here as well.
Yeah, still says waiting.
Going to the Bytecode Alliance page, I can see the live stream that seems to be working from the top, but the original link doesn't. Yeah, it's a different link. Going to the Bytecode Alliance page, I can see the live stream that seems to be working from the top, but the original link doesn't. Yeah, it's a different link.
Let's move to the new link. The RMTP credentials that we put in should have worked, and it was streaming somewhere. I have no idea where though. Zoom did the handshake and it worked, but did not go to the pre-posted YouTube live. So I'm gonna run around and update the live link in a lot of places, but if you're here watching this now, then it worked for you because you found the new link. Yeah, thank you, Victor. We'll post it all around and get it edited. Sorry about that technical glitch.
Is there any way to update the old link telling people where to go? Because there are 32 people waiting apparently.
Yes. I'll work on that.
All right, so we'll give folks maybe 2 minutes to get onto the stream, and then we'll re-kick off the intro, and then we'll go from there. So we appreciate everyone's patience with our technical difficulties, but one of the beautiful things about WebAssembly is, we're going to solve every engineering problem that's ever existed. All right, authentication, keys, why not WASM, right? In fact, there probably is WebAssembly being used in the streaming of this meeting right now. So all right, I'm going to call that enough time, and we're going to kick it off again. So welcome, everyone, to the Bytecode Alliance Plumber Summit, Day 1, February 2026. Some quick housekeeping. If you're coming to us from Zoom or YouTube, there is a Zulip chat that we ask that you use for all of the questions that you have. And when the presenters are done speaking, we'll take questions from the Zulip chat, and we'll make sure that they get answered live on the stream. I will also say that all of this will be recorded and will be posted to the Bytecode Alliance YouTube. So if you need to step out, don't worry too much about it. The agenda today, it's going to kick it off with Luke Wagner with current plans and technical roadmap for the component model. Then Cybran with cooperative threads. Alex Crichton with a tooling roadmap discussion. We'll have a short break. Joel Dice will come on and talk about guest languages. Victor Adossi and Luke again will be here to talk about JCO and browsers. With that, I do ask that everyone adhere to our code of conduct. Please be kind to each other, but if you haven't taken a look at the code of conduct, there should be some links flying around in the chat right now. Please go take a look at it and please be respectful of it. The last thing is that WASM.io, 2026 actually, just realized that, March 19th and 20th is taking place in Barcelona, Spain. Many folks in the WASM community are going to be there. You still have an opportunity to get a ticket and go be at WASM.io, and we'll be excited to see everyone there together. With that, I'm going to kick it off to Luke.
All right. That work?
Looking good.
All right. So, hello, my name is Luke Wagner. I work at Fastly. I'm going to be talking about current plans and technical roadmap for the component model. And this is a draft because it's something that we'll be discussing both at the end of this talk and over the next 2 days, the virtual summit. So it's a good time to give feedback. Also, feel free to follow up offline on Zulip or emails. And the plan is to have a distilled version of this presented at WASM.io for to share the roadmap more widely. So then, just to start off, I'd start off everyone on the same page. I'd like to briefly recap why we even need the component model in the first place. So one high-level goal that I think we all share is we'd like to see ubiquitous upstream support for WASM in all the major languages, packages, and frameworks, so that WASM just works everywhere, inside, outside the browser. Now we're already off to a great start here. As we can see in this list, lots of languages already have some degree of support for generating core WASM, but to get from some support to a just works developer experience requires more than just time and efforts on the part of each of these languages communities. And that's because the core WebAssembly standard leaves open questions that individual projects need standards-based answers to, since they have to be implemented in a coordinated manner across many distinct projects, including WASM engines, language producer toolchains, and low-level tools like LLVM, libc, and the linker. In particular, we need standards-based answers to questions like, how are WASM modules bundled together into publishable, distributable artifacts? How are WASM modules linked together at runtime with control over the sharing of memory and functions? How do WASM modules communicate values and handles when they don't share memory? How do languages, standard libraries, and packages perform standard I/O with things like files and sockets? How do host embeddings define their own custom I/O APIs that integrate well with standard I/O APIs? How is I/O virtualized in WASM for use cases like polyfilling, adapting, tracing, and proxying? How do WASM modules opt in at the ABI level to new WASM features like multi-memory, Memory64, and WASM-GC? How do languages implement their concurrency mechanisms like callbacks, async await, and threads? And finally, how are module instance lifetimes controlled by the host and other WASM modules? And not only that, but when we consider all the places that folks are running WASM today, we need answers that work across a variety of axes, including from whole WASM apps to small WASM plugins in big native apps, from the full kitchen sink of OS capabilities to pure computing environments like database UDFs, from beefy server hardware to tiny microcontrollers, from single language monoliths to highly polyglot composite applications, from isomorphic modules that want to run both inside and outside the browser to specialized modules that don't. Now what we can't do here is try to standardize the least common denominator across all these axes, because that's all you'd be able to basically do is build a calculator. Instead, we have to embrace the heterogeneity of the WASM landscape while still finding enough commonality to prevent fragmentation and duplication of effort. So to do that, we've adopted a layered approach where we slice up the problem into two layers. Lower layer is the component model, which provides common answers to all the questions except I/O, while running across all these diverse axes of host environments. And then the upper layer is WASI, which uses the component model to define a collection of standard APIs for all the different kinds of I/O that may or may not exist on a particular host. And you could say this is roughly analogous to a classic microkernel architecture, where the component model is like the always present microkernel, providing foundational primitives, and WASI is like all the OS processes for networking, storage, and graphics that, depending on the device, might not be present. Another reason for the split is that because, like core WebAssembly, the component model doesn't have any built-in I/O, the component model can be implemented natively in the browser alongside core WebAssembly. In contrast, browsers have the very strong opinion that web APIs are the only I/O APIs, and thus WASI would need to be implemented via browser polyfill. And so, in summary, we need the component model to provide standardized answers to questions left open by core WebAssembly in order for us to get upstream support across the software ecosystem so that WASM just works across the diverse set of places that we want to run WASM. So that was the why. Now let's talk about the when. And so as background, WASI Preview 1 started with an initial set of POSIX APIs, and then Preview 2 split out the component model layer to answer a bunch of the questions I just listed, and also added sockets and HTTP to the WASI layer. And any day now, we'll be releasing Preview 3, which extends the component model to answer a bunch of concurrency questions and add async functions, streams, and futures to it. And there's been a metric ton of work from like 20 people across 8 organizations and the community on Preview 3. So a big congratulations and thank you to all involved. Well, we've also done a lot of work on cooperative threads, which I sketched at last year's Plumbers Summits, and my colleague Cybrand will be talking about in a lot more detail next. Now, we're not quite done yet. There's a bunch of spec tweaks, or a number of spec tweaks and a bunch of toolchain integration work to do. But as soon as that's done, cooperative threads will go out in the next 0.3 minor release, taking advantage of the 2-month release cadence that we set up in 0.2. There's also another small but important addition we need for streams, which is the ability to splice one stream into another without an intermediate copy. It's very important for performance. It just didn't make it into 0.3.0 in time. Now, in 0.3.0, we didn't add any new WASI APIs. We just upgraded the old ones to use new WIT features. But with our concurrent foundations built, we'll resume adding new WASI APIs in 0.3 minor releases, with good next candidates being config, key value, and object stores, crypto, and OpenTelemetry. But likely many more, because with our heterogeneous layered approach to APIs, the more the merrier, and it mostly just comes down to who shows up to the WASI subgroup with multiple interoperable implementations. So then what's next? Well, first, what we're not going to do is a preview 4. Instead, it's time to turn our sights to a component model 1.0. What all goes into 1.0 and when will it be done? Well, that's what the rest of the talk is about. But as a summary and outline for the talk, the plan is to improve the ABI based on feedback we've gotten from the previews, then motivate native browser supports, make it easier to implement the component model, grow the ecosystem, and finally close key expressivity gaps that we've seen in practice. Now, the other half of the story is, of course, getting to a WASI 1.0, but that's dependent on a component model 1.0 and will have to be the subject of a later discussion since this presentation is scoped just to the component model. And one last key part, the whole plan is to maintain stability, which we've been doing since preview 1, using a combination of semantic versioning, side-by-side implementations, and WASM to WASM adapters. Stability means that you can ship stable preview 1 releases in production, and indeed a number of us already are. And our intention is to keep the stability story well past 1.0. So while we definitely do want to get to a formal 1.0, you can start using this stuff now. So now let's go through these 5 to-dos, my list, in more detail. So the first to-do is to improve the component model ABI based on the feedback and experience we've gotten since the release of WASI Preview 2. And when I say ABI, I'm referring to the core WASM function type and runtime behavior that correspond to a WIT-defined interface. And a powerful thing about the component model is that its ABI is parameterized by a small set of ABI options that each component gets to pick internally to configure important details like string encoding and multi-memory. Now, as I said earlier, we haven't made a breaking change to the ABI since the release of Preview 2. Preview 3 just added a new async ABI option that components can use to opt in to being more concurrent. But of course, the whole point of these preview releases is to collect real-world feedback that we can learn from and then iterate on before a final 1.0, and indeed, we've gotten some useful feedback. So, as a background, if I import a WIT function returning a list of strings, ABI requires the caller to specify a function that we usually call cabireallic. And when the caller calls the imported WIT function and the callee is ready to return its value, the host calls cabireallic to allocate memory for the elements of the list. And then it calls cabireallic again for each strings char buffer in the list, and then copies everything before returning to the caller. And while this works pretty well in practice, the feedback that we've gotten so far is that a generic cabireallic can lead to heap fragmentation over time. Handling large allocation failure gracefully without trapping is hard. Performing one host-to-guest call for each value can be expensive, and it's hard to implement various custom allocation schemes. So to address this feedback, the alternative approach we're considering inverts control flow, so that when the callee returns a value, instead of the host eagerly calling cabireallic and copying each value, the host instead returns lazy values as i32 handles. And then when the caller is ready to copy the value, it calls a special built-in function, passing the destination address as a parameter. And because these built-ins are statically known to the compiler, they can be inlined as if they were instructions. And I think we'll be hearing more about that tomorrow in the summit. And I'll show an example of what this would look like from guest code in a few slides. But for now, I'll just drop a link to component model issue 383 for more details. But with this change, not only do we get to address all the feedback that I just mentioned, but we also get a bunch of other nice-to-have hop-ons, such as allowing lazy values to be zero copy forwarded between function calls and dropped if they aren't used. The lazy approach also allows the caller to set different ABI options for each value instead of for the whole function call. And it should actually simplify engines by moving some ad hoc string transcoding and auto backprocessor auto back pressure policy choices into WASM guest code. It'll also simplify Hello World components by removing the call indirect shenanigans that confuse newcomers when they look at their first component. And they're like, what's all this stuff? And lastly, the lazy approach sets us up well for post 1.0 additions like the ability to gather a single list via IOVEC and the ability to have recursive WIT value types. So a lot of great stuff falls out of this change. But how do we roll out an ABI change while maintaining that all-important stability guarantee I just mentioned? Well, the plan is to add a new lazy ABI option as part of a 0.3 minor release so that producer toolchains can gradually opt in when they're ready. And then when we get to 1.0 and everyone is opted in, we can make the ABI always lazy and just remove the option because it's the only thing. And because the lazy ABI is more general than the eager ABI, we can build an adapter tool that converts any component from eager to lazy. And then once we have an opt-in, we can also fold in a few unrelated but otherwise breaking ABI changes that we've wanted to make for a while now. One is to finally take advantage of WASM multi-value in return types. And another is to include an error context value in every result values error case so that there's always a nice idiomatic way for hosts to attach backtraces and debug info to errors. So when might this happen? Well, the current plan is to start working on this right after closing out the cooperative threads that I mentioned earlier and Sai will be talking about next. Then hopefully it won't take too long because it's a somewhat narrowly scoped change. However, waiting for an LVM release with multi-value return support may end up being the long pull here. Lastly, there's one more orthogonal ABI improvement that I think we need before 1.0, and that is adding a GC ABI option that configures the ABI to use WASM GC allocated memory instead of linear memory, avoiding what would otherwise today be a copy through linear memory. Now, I'm not sure when exactly this work will start, but there's already a great pre-proposal by Nick Fitzgerald in Component Model issue 525 that you can check out if you're interested, and then maybe pitch in. So in a nutshell, those are the ABI improvements that we're planning to make before 1.0. The second to do is to motivate browsers to implement the component model inside their existing JS WASM engines. Now, we don't depend on native browser support since we can already run components JS engines today using Jco transpile, which converts a component into equivalent core WASM and JS glue code. And Jco already makes using WASM from JS a much nicer experience. You just import the component's exports using a JS import statement, and then you can call or await them, and you get to pass and receive normal JS values like strings, arrays, objects, and so on. And since this works today, we don't depend on browsers adding native support, but it'd be a lot cooler if they did. Why? Because there's already some performance gains to be had. At load time, a native implementation could call directly from WASM to browser APIs, skipping the JS glue code. Now, how much real-world speedup there is to be had will obviously vary by workload, but some experiments by Ryan Hunt at Mozilla show that even during doing DOM mutation in a WASM VDOM reconciliation loop can get an almost 2x speedup from direct WASM to browser calls. But there's also a more subtle, powerful reason to want native browser support, which is that browsers are a major gravitational force with massive reach. And when you combine the browser's reach with the component model removing the toolchain dependency on JS, the result should be a major increase in upstream WASM support in languages, packages, and frameworks that would then feed back into a better developer experience for WASM on the web. And fortunately, based on these and other arguments, browsers are starting to seriously consider the component model. The Mozilla folks gave a great presentation at the last in-person WASM CG meeting covering the performance experiments that I just mentioned, and generally making the case why the component model would help make WebAssembly a first-class citizen on the web. And the Chrome V8 team recently created an issue for evaluating the component model and collecting feedback. But of course, the component model is not exactly a tiny feature. I think it's about as small and simple as it can be given all the questions it needs to answer that I listed earlier. But it's a bunch of work to implement, and so some due diligence on the part of the browsers is appropriate. And one way to do this due diligence is to demonstrate growing real-world usage of Jco transpiled components so that the native support is just paving the cow path, which browsers like to do. So to enable this, we're having Jco emit a use Jco no-op string in the JS glue code so that browsers can report it in their existing feature usage telemetry. And for anyone familiar with the history of WebAssembly, this is kind of like how we started with ASM.js, which contained a use ASM no-op string that helped motivate Chrome in particular to optimize ASM.js and then add WebAssembly. So one thing I'll encourage everyone here to do is to use Jcode to simplify your WASM web development experience and help us juice those telemetry stats. But this does mean that getting something shipping in browsers is going to take some time. And according to the WebAssembly CG process, we can only get to an official 1.0 if the component model is shipping in at least 2 web VMs. So then that naturally raises the question of, what should we do in the meantime? Which is the context for the last 3 bullets in the to-do list I gave at the beginning. There are valuable things that we can do to take us toward our goal that don't significantly increase the implementation burden on browsers, which is going to be our long pole here. So then, third to do is to make the component model easier to implement. And I think there are roughly 2 big categories of implementations here. Got producer toolchains compiling source code into components, and WASM runtimes executing components. And for both of these, there's an opportunity to factor out some common implementation work into shared tools. The high-level idea here is to boil WIT down into a pair of traditional C ABIs, one for the guest and one for the host, both expressible as header files. So let's dig into each one, starting with the guest C ABI. So the idea here is to use WIT bindgen to compile WITs into C header files that exactly match the component model ABI. For example, if I have an interface foo containing a function bar, this would turn into an extern C function declaration that uses Clang attributes to mangle the interface name foo along with a version and the choice of WASM32 into the import name of the function bar. And then following the ABI, the WIT string parameter s would be decomposed into a UTF-8 pointer and length parameter, which are then both compiled down to core WASM-I32 parameters. Now, string value here is a struct, which today would need to be returned via linear memory. But if we're taking advantage of multi-value returns, we could add some sort of new calling convention, which I speculatively called WASM multival here, that says to return structs as scalar return values when possible. And what's in this struct? Well, if we're basing the guest C ABI on the lazy ABI, it would be an opaque lazy value index, along with the required buffer size. And when the caller figures out where they want to put the string in memory, it would call a lower string built-in function, passing the lazy value index and a destination address. And that's unfortunately all the time I have for this example, but if you want to see a fairly detailed sketch of what the guest C ABI would look like in a preview 2 timeframe, check out component model issue 378, where we were calling it a core WASM build target. Maybe guest C ABI is a bit nicer name. But then zooming out, the point of all this is that now I can compile my source code to a core WASM module as usual, and then feed this core module into a WASM component LD along with the original WIT to wrap it up into a proper component binary. And yet, I don't have to learn a bunch of new componenty things. I'm just calling core WASM imports via C headers, kind of like with Preview 1, which is nice. Now, technically, this guest C ABI will only be able to express a subset of what the component model allows in terms of bundling, linking, and ABI options. However, we can expand the subset over time by adding new built-ins and name bangling options. But if nothing else, the guest C ABI is a great way to help folks get started. And in terms of timing, to minimize churn, we probably want to wait for the lazy ABI to stabilize first. But what's convenient is that the guest C ABI is purely a toolchain convention, which means that it doesn't require any WASM runtime support or a dot release. So that's nice. And that covers the guest C ABI. Now let's switch over to the host C ABI. Now you may be wondering, well, why do we even need a host C ABI? Can't the host just implement the guest C ABI? And the answer goes back to how I was saying that the guest C ABI can only target a subset of the component model. So that means that there are components sitting outside this subset that the host still needs to run, such as compound components produced by WAC that internally contain multiple modules and memories all linked together. But what we can do is leverage core WebAssembly features like multi-memory to smash everything together into a single core module that has the same observable behavior as the original components. And then the interaction with the outside world, with the host, could be governed by a host C ABI that could be generated from WIT by WIT bindgen. And this host C ABI would be pretty close to the guest C ABI, but have some key differences like passing extra parameters that host functions need, like the memory index and the ABI options to use. But with these, a core WASM runtime could implement this host C ABI just like any other core WASM interface. Now, this component smashing tool doesn't exist to date, but already Jco and ArcJet's Gravity, which is built on WAS0, are doing something sort of like it by reusing parts of WASM time. So we could pave this cow path by building a proper CLI tool, which I'll tentatively call lower components. And then using lower components and with BindGen, we could more easily add component model support to other core WASM runtimes like Wagner. Now, I'm not sure when exactly we'll have resources to do this, but in general, it seems like a good idea, and I believe we'll get a Bytecode Alliance RFC written up pretty soon about this for more technical discussion. And so then zooming back out, with the C ABIs and shared tools, implementing WASI and the component model should be about as easy as WASI Preview 1. And this isn't just a story of there and back again. What we've gained in this process is standardized answers to questions around bundling, linking, virtualization, APIs, and concurrency across the heterogeneous landscape of custom and standard I/O, now including sockets and HTTP. So it was worth the trip. Moving on, the fourth to-do for a 1.0 is to grow the ecosystem around the component model. And there's several big ways for us to do that. The first is to write more and better documentation. And of course, we already have an online component model book, which is a great starting point. And there's now also a physical book called Server-Side WebAssembly by Dan Charloni, which is awesome. And congratulations, Dan, for doing such a good job describing the state of the art. But of course, there's still a lot more introductory, tutorial, and reference content that we need to write for each language runtime and tool. Another big way to grow the ecosystem is to get stable 0.3 support upstream in all the places. There's already some great progress that you can track on Yosh's awesome WASM components repo on getting WASI P2 and P3 implemented as downstream tools, and in even some great first steps towards upstreaming in LVM, Rust, Tokyo, and Python. But we should do a bunch more. And the last big way to encourage growth is building and improving generalized component tooling that is useful across all programming languages. One such tool is, of course, Jaco, which is not just a component polyfill, but also provides experimental WebIDL imports that allow any language with WIT bindings to call any standard web API without having to deal with any JavaScript. And there's a lot more kinds of tight web integration we should add to Jaco. Another great tool is WAC, which lets you easily plug components together from the command line or using a powerful little linking language to create more sophisticated compositions. But we've all only just scratched the surface of what's possible with WAC, and I think we should take WAC a lot farther. Another important tool is Wackage, which allows publishing and fetching components to and from standard OCI registries. And it works, and some of us are already using it in production, but it'd be great to build higher level tools for discovering and depending on components in OCI registries. And lastly, there's some ongoing work on record and replay debugging that's really exciting and uniquely takes advantage of the shared nothing nature of components. And these are all tools that have already started, but we should start even more. And so that's an overview of some of the things we should do to grow the ecosystem. And the final to-do that I'd like to cover is to close some key expressivity gaps that we felt with our current preview releases. And just as a caveat, the exact names and WIT syntax here is just me speculating, hence the crystal ball emoji. So the first feature, which we've been unofficially calling Stream to UV, is a result of our experience working on WASI HTTP. So in 0.3.0, to fully capture all the concurrent things that can happen while consuming a request or response body, we need a rather complex function type that looks like this. So here we're returning a stream of bytes along with a future that resolves after the stream is done with either the optional trailers or an HTTP error. But we also want the consumer to be able to pass an error back to the producer. And so we have this extra return future as a parameter to the function. But the net result is that it's sort of hard to make sense of this function when you just look at the WIT. So the idea is that instead, we could write this, where our consume body method just returns one stream that produces a sequence of bytes and then a final result that's either the optional trailers or an error code. And then finally, the stream consumer can return a value that flows in the opposite direction back up to the stream producer. And again, I'm speculating on the syntax here, replacing the commas in stream to UV with the keywords then in return to try to make it more readable. But whatever the final syntax, it seems like this generalization of stream would be useful, not just for HTTP, but for any sort of streaming protocol that has state transitions, just like a lot of them. So that's an additional thing we've been discussing. Another is optional imports, which would allow a component to say, for example, that while it needs to make outgoing HTTP requests, it only optionally requires a web GPU device. And in the guest C ABI, this optionality would translate into a special feature test function that WASM would need to test before calling any of the real web GPU functions. And this is particularly useful for languages' standard libraries to optionally import everything so they can generate components that run on minimalist host embeddings without having to jettison the whole standard library. The next feature is callbacks. which would, for example, be what you'd need to express the DOM's add event listener method in WITs, which we want to do. Now, there are some very subtle cyclic lifetime hazards that we've learned from our browser experience, but I think we can address them if we have careful scoping rules that ensure that callbacks are GC edges and not GC roots. Another important gap highlighted by web APIs is resource subtyping. For example, we'd like the resource type for DOM nodes to extend the resource type for event targets so that all the event target methods can be called on nodes. Although this sounds like it might open an object-oriented can of worms, this would just be subtyping, not subclassing. And so there'd be no virtual dispatch or complex inheritance stuff for engines to worry about. We also need function subtyping to ease API evolution by allowing WIT interfaces to add function parameters, record fields, and variant cases without having to introduce wholly new functions or declare breaking changes. In theory, this seems simple at the WIT level, but the tricky thing is that we have to think through what happens in all the language bindings so that we can convince ourselves that a WIT level non-breaking change doesn't turn into a source level breaking change. But yeah, we need to do that because evolving WIT interfaces is kind of a pain at the moment. Another important feature is more expressive import and export names. For example, I'd like to be able to import two WASI key value stores, one backed by Redis and another backed by Memcached. And I'd like to include the internal store IDs of my platform in the import names so I can catch and report misconfigurations at deployment time instead of at runtime. And there's a bunch of other ways we can use this feature to improve the developer experience by servicing component dependencies declaratively. Next, getters and setters would allow more idiomatic WIT bindings in many languages. And like constructors and methods, which we already have, getters and setters would just be syntactic sugar for regular functions with special names that the binding generators can recognize. And a map type would allow WIT bindings to produce and consume idiomatic objects, dictionaries, and associative arrays. And indeed, Yortis Prieto is already working on them, so thanks, Yortis. And the last key feature is runtime instantiation. Now, this is something you can do in browsers today using WebAssembly.instantiate. And it's super useful if you want to lazy load code when it's first used, or spawn WASI CLI components as subcommands, as they're called. Or in general, give different components different lifetimes. And you may recall that lifetime is the last open question on my list of questions that need standardized answers. So this seems both pretty useful and also not much extra work for browsers given that they've already implemented something even more powerful in the JavaScript API. So that's a summary of the features we're thinking about adding in a 1.0 timeframe to close expressivity gaps. Of course, we might not get to all of these before 1.0, and there's likely other small things that will get added if we find the need, time, and resources, but it's the current working draft. And so, final summary slide, which I'll kind of leave up for discussions. Summarize the kind of the roadmap here. Talking about, first, of course, ship that 030. It's so close. Just, a few little things to finish up. And then ship cooperative threads and stream splicing in some 0.3 minor releases. Then improve the ABI with laziness, error context, multi-value in some 0.3y later minor release in an opt-in non-breaking way. And then after that, implement the guest CABI. So we have that works like WASI P1 for producer tools experience. And optional imports, which pairs really well with the guest ABI because it kind of gives us a really clean answer for what do I do in my standard libraries if I want to be able to target components of any world and not force everyone to import file system sockets all the time. But still, I want things to just work. Optional imports gives us that answer. And then in some TBD order, while waiting for browsers, but also not blocking. If browsers are ready, like anything that's not ready can be a 1.x, is all those things I just talked about. And then in parallel to all that, should be improving documentation, upstreaming 0.3 stuff everywhere based on our stability, and improving cross-language tooling, especially around Jaco, Whackage, Whack, and record and replay debugging, and hopefully more. And lastly, if we can get it resourced, then the host CABI. So that's it for me. I'm happy to have some discussion.
Thank you so much, Luke. I can tell folks are being a little bit shy in the Zulip chat. There was not a single message of bike shedding on WIT syntax, which is truly astounding. But folks, please ask your questions in the Zulip chat. If you are on the Zoom and you want to come off mute and ask a question or have a comment, please do so at this time. I'm going to relay some questions here. So does component model 1.0 mean phase 4?
Yeah, that's what it would mean. And that's where you get that WebVM, 2 WebVM requirement in the CG. Unless we modify the phase requirement, which has been discussed. But at the moment, it's 2 WebVM requirement. Yep.
And then another question we've got in the Zulip. If someone wanted to contribute to one of these, how would they do it?
One of those, well, there's lots of different projects now, lots of ways to contribute, right? So lots of language tool chains, each with their own, lots of bytecode lines projects, the component model repo, if you want to participate in one of those, and especially on that last slide in the closing expressivity gaps, the WIT features, component issues. Actually, Bailey just opened one this morning, which is exciting for the more expressive imports and exports. So, component model repo for standardsy stuff and WIT stuff, and all the different bytecode lines projects. And yeah, there's so many ways that I can even summarize them all. But I don't know, everyone else, please jump in with more.
A little bit more on that one, I guess. I think there's you start with a discussion over on one of the issues you linked on your WIT expressive slide. I imagine then if we have a general agreement on that approach, then it would be starting discussion over in WASM tools for a sketch on how we could implement it inside the parser and the changes that would be made there, I think. And for that, I would want alignment with folks like Joel and Alex on those changes and their eyes on it probably before you get too deep in the weeds on implementation. Just starting with the sketch probably is the right move. I'm also asking because, yes, I just put in that PR and now I want to know my next step and, what's the right move.
So there was a question that was maybe a little bit of a joke in the chat by Victor. Does the bike shedding start now, Luke?
I think the best place for a particular scope feature would be in a component model issue where we kind of talk through the syntax. Yeah.
Bike shedding with steps. I love it. We have another question. Can those WIT expressive changes happen in parallel?
Oh yeah. Well, there's a lot of parallelism opportunities with all those features mentioned. A lot of it's just prioritize. The best time to do a thing is when you have a use of it yourself, because then you can be the first lead user of it, the dog fooder of it. And so a lot of these things we're scheduling as needed. Each of these is a felt thing, but it's just a matter of when resources are available. So there's a lot of parallelism opportunities. Sure.
We have another question here from Eric. Seems like parameterized imports would be semantically equivalent to providing some parameterizing module to the imported module. Is the motivation to save the heavyweightness of instantiating a whole nother module?
Let's see. I didn't quite follow the full question there. It's is maybe whoever asked that could ask it in
yeah, I think Eric's
detail
on the Zoom.
Yeah, it's hard to say because you say import a lot of times,
Yeah.
but it looks like you're passing strings into modules.
Right.
You could also provide a second module that has a function that returns a string for that first module to call. Bunch of dancing around.
Got it.
So
this is for that generalized import and export names. This, maybe I'll point at it. Oh, yep, here it is. This one.
Yep.
Yeah, so the idea is this stuff, what's in purple, is all of it's getting mangled into simply the string name. And you could say at the moment, our string names can either be plain names, which have no standardized meaning, or interface names, which have a very standardized meaning, but you can just have one of them, and it's just that interface name. So you have two kind of faraway options. There's like, I don't know what this is. You're gonna have to figure it out yourself. And this is blessed by WASI or my platform of choice, and has a namespace and a package name and interface name. So what we're saying here is, well, what I want to say is, I'm going to tell you what the semantics is, and that's what WASI key value store says. Well, that's defined by WASI. We know what the WASI value store is. But I want a little more metadata that I can find in that import string, such as this is stuff that when I'm deploying, I'm going to say, does my host actually have a store one? Like this, this attachment, you might call it. Does this exist? And then when I'm code genning my source code bindings, here's a nice programmer identifier that's going to be a global variable that I can use to call key value store methods. So we need, I think, in general, both of these strings. This is like what the programmer gets to use. This is a kebab case thing that gets localized into an identifier. And this is metadata parsed out by the host. But it all goes into the string. So this is just what goes into a name of an import. And this is stuff we would have to put in a separate JSON file or a custom section, but those get lost. Those get split. They come out of sync. Putting it right in the import string like kind of puts it where you want it. And so it gives us the best option to like give us that deployment time error checking instead of what tends to be lazier runtime errors. So.
Thank you.
Yeah, it's a great question. It's definitely a nuanced topic, and it's going to bear a lot of discussion. It's kind of funny. It's going to be very easy in the runtime. It's just string validated. It's just like the regex gets a few more cases. But how will the tool chains interpret it in all the, for all the build tool chains and how runtimes? That's where all the interesting stuff is. So, yeah.
All right. Well, thank you so much, Luke. That's all the time we have for this session. And so we're going to move on to Cybran with cooperative threads. Cy, please take it away.
Hello, hello. Okay, I am sharing. Are we all good?
We're good to go.
Great. Hey friends, I am Cybrand. I work at Fastly on WebAssembly stuff, and I'm going to talk about cooperative threads. So I'm going to walk through a kind of high level look at the design, and then talk through current progress on the implementation, and then a high level timeline for when we might expect all of this stuff to be available to play around with. Lightning fast intro to what cooperative threads are. Basically, what we're implementing here is something that's concurrent, not parallel. We have sequentially interleaved threads with explicit switch points. What that means is that you have a bunch of functions, a bunch of tasks, which you want to run concurrently, and those can be switched out at very specific points that you can see and write code for. And this is going to be something that enables a lot of code that uses threads to kind of just work. So it can be a stopgap to shared everything threads. If you have code that you're trying to port to WebAssembly that uses threads, this might fulfill your needs. A kind of high level look at the design. Say we've got this WitWorld, that's the Byte Alliance cats package, and it has a cat. Like any cat, the two things that it does is go about its day and import WASI file system. And we might want to implement this world in Rust, so we could generate bindings against this world. And maybe we write some function that's going to log to a file, and this is going to use all of the WASI file system API. And then we start implementing our go about day function, which is asynchronous. And maybe we want to go do some of our work in a separate thread. We're going to spawn a little worker thread to do some cat things, and then yield now, which I'll talk about in a sec, and then do more cat things. This yield now thing, what that says is, just in case anyone else wants to do any work, I'm going to let some other threads run. I've done a bunch of cat things, and now it's time for someone else to have their choice. And then in my original thread, maybe I just log to a file that I'm off doing cat things, and then join the original thread. So the cooperative part of the threading here, note this kind of looks like general multi-threading. In Rust, we're spawning some threads, which are going to go off and do some additional work. Cooperative part is, one of them is here. This is an explicit yield point where we are giving up our scheduled time. This will commonly be used if you are doing very CPU-bound work and you don't want to just block every other thread from making forward progress. The other main yield points will likely be somewhere in this log to file function. If we call something which blocks, we don't want to just be waiting around. We want to give some other thread the opportunity to run. And the specification for all of this, which I have a link to in a bit, enumerates all of the places in which you can be switched out. The kind of high-level design of this, if we call cat.goaboutday, if we're some component and we have imported this function from another component, this is going to create a task. Every call to component model export is going to create a task, which represents all of the work which needs to be done in order to fulfill this export call. When you create a task, this is going to create a thread implicitly. So any code which is running inside component model export is going to be running on some thread, and by default, that will be the implicitly created thread. But of course, like we had in our thread spawn, we can go off and create our own explicit threads and then do separate work in those. And maybe we yield execution, we go back and we call cat go about day again, which is going to create a completely separate task with a separate implicit thread, which can then go and spawn its own explicit threads. So this is the kind of relationship between tasks and threads that we're going to have. All of this is built on a bunch of intrinsics, which gives you the kind of base level functionality of threading. So some of the main things you want to do are you want to create a thread, you want to maybe get the index of the current thread so you can communicate about it. You want to be able to switch to some other thread to let that one do work. You might want to just yield back to the scheduler and say, hey, run whatever you fancy. And you might want to say, hey, I know this thread over here is suspended, go run that later sometime. And these all have a bunch of intrinsics which map to them. Most of these are one-to-one. We've got thread new indirect for creating thread index. The one here which has a few options is when you want to switch to another thread, there's a few options whether you want to leave yourself suspended or leave yourself available to be scheduled at a later date. And there's some nuances here that I don't really have time to get into right now. These are not entirely represented in the specification yet. Luke is working on some PRs for that. Over the course of implementing pthreads, we found some changes we wanted to make sure that everything can be as efficient as possible. Those will all be coming, but if you want to know about any of the details of this, you can feel free to ping me on Zulip or Luke. And this is the specification that you can go have a look at. Especially the concurrency explainer is going to go into a lot of detail about the high-level design. So implementation progress. This is at the high level of a lot of different components that are involved in toolchain. So I've been focusing on the kind of guest language through LLVM and WASI-libc through to being run on wasmtime toolchain. JCO is very separate from that, and I've not looked at that at all yet. So that's marked as not started. Guest language support, like actually spawning a thread from Rust, also not started yet. The stuff that has been done is WASI-libc, which is where the implementation of pthreads lives, and that's going to form the base of all of these other guest languages. That is all more or less done, and it's kind of awaiting a lot of things being merged into LLVM. And before we can then upstream all of this work from my branches into WASI-libc and have it all tested. There are a series of patches for Clang and LLVM and the linker, one of which just landed, literally got an email about it 30 seconds before I went live. So that's good. Hopefully all of this can get merged soon. But I'll go into a bit more detail about that in a second. WASM tools, that's all done. WIP bindgen, we have support for the C generator because we need it for pthreads implementation. And this is mostly for if you want to call these threading intrinsics from code you're binding against. And then the wasmtime implementation is functional. There's some key optimizations that we need to make, but the basic support is there. So going through these kind of step by step to give you more details, pthreads is the big thing in WASI-libc. And you might think of pthreads as just, oh, it's a pthreads create, it's a join. Sure, that's the kind of most important thing that we care about here. But it's also all of these primitives like mutexes, conditional variables, semaphores, barriers, read writer locks. All of these have to be implemented with the intrinsics that we have in order to really make the most of them. So I've done all of this. C11 threading it can be built on top of pthreads pretty easily, so that kind of falls out magically. Testing is another large component. There are a few tests in the muzzle libc suite which we use. But I have been adapting the OpenPOSIX test suite for WASI-libc, which has about 400 pthreads tests. Many of those are simply not going to work on our platform because they do like a fork or signals or things like that. But there's about maybe 170 that are usable, and of those, I passed about 150 of them right now. The others are things that I've simply not implemented, like timed joins. So progress is good there. This will all get merged into WASI-libc over the coming months. Clang and LVM, the linker, the big thing here is a new thread context API. What that means is that in C or some high-level guess language where you maybe want to take the address of something, then you need to have somewhere to store all of your data so that you can get an address in linear memory, which means you need a stack pointer. And for thread local storage, you need some pointer to the start of the thread local storage block. Those used to be just global variables, which, of course, if you have multiple threads running, is not going to work. So we now have context.get and .set intrinsics for both the stack pointer and thread local storage. So this completely changes the way that LLVM generates stack pointer and TLS code. On the kind of higher level of how you interact with all of this, there's going to be a new flag called component model thread context for Clang, which is going to enable this new API, and it's going to be the default for the WASM32 WASI-P3 target. Very similarly, there's going to be a WASM feature flag with the same name, and if you try to mix and match LLVM versions, you'll get a linker error. So this will not just fail at runtime or anything like that. Also some miscellaneous changes like assembler improvements and some fixes for dynamic linking in the face of thread local storage. So those patches are all currently being reviewed and will hopefully land soon. WASM tools has been updated for all the new threading intrinsics. So if you use any of these crates, WASM encoder, parser, printer, WASP, wait component, all of those have been updated with the new intrinsics. Right now we're using a very kind of temporary ad hoc symbol ABI. My hope is that once we really get all of this nailed down, we can go back and really tighten this up and get something that is standardized and well documented. We also importantly have a new ABI for task initialization. So remember when you call some export, you get task, which should need to set up the stack pointer in the TLS base. So what we do for that is WASI-libc is going to create this function called WASM init task or init async task, and wait component ensures that calls to this get injected into every component model export. So you always have a valid thread context set up. And WASI-libc implements those. With bindgen, that needs support for the new threading intrinsics. Right now, that's just in the C generator because I needed it. The other ones are not yet supported, but it should not be too much work to add them if that's something that you need. WASM time, all of the threading intrinsics are implemented. They're under this component model threading feature flag. There is some outstanding work on things like minimizing performance impact for when you have synchronous code calling synchronous code. We don't want to add a bunch of additional runtime overhead into your synchronous code paths. And we'll also need optimizations for those thread context. We don't want it to be that whenever you need the stack pointer, which is in every function that uses the stack, then you have to call a function to get the stack pointer. That will not be fun. So that really needs to get lowered to single loads and stores. So there's some optimization work that will need to be done. There's also potential future work for automatically inserting automatic yield points. So if you want to adapt some code that is very CPU bound and doesn't have yield points there, maybe we can insert them into function prologues or loop headers, things like that. JCO, as I said, my current work has been focused on the LLVM through to WASM time toolchain, and I'll be considering what needs done in JCO after the important parts of this have been merged. timeline. So there's some kind of key dependencies here. You might imagine a possible timeline could look like this. Maybe our LLVM patches get merged in March or something. The next LLVM release is in July. And I would really rather not wait for that to get all of this stuff merged and then have WASI SDK threading support in some point after that. That doesn't sound very fun to me. But we do need a way of actually testing all of the pthreads implementations in CI for WASI libc so that we have confidence in actually shipping this. So what we're going to be doing instead is hopefully LLVM patches get merged soon. Once that happens, we'll release an experimental WASI SDK, which does not include pthreads, but does include the new thread context ABI targeting. So this will use the new LLVM flags. With that, we can then bootstrap all of the merging of pthreads into WASI libc, resulting in a new experimental release that has full support for pthreads. Then when the official LLVM release comes out, we're already pretty much good to go. And shortly after, we can make an official WASI SDK release, which has threading support. And then I think within a couple of months or so, we can enable guest language like Rust to use this threading enabled WASI SDK release. So that is kind of my broad thoughts on the timeline here. I haven't included JCO here because I don't want to make any promises about that yet, having not looked at it. These are current feelings. I do want to give a huge thanks to all the people who helped me. I basically came into this maybe 6 months ago, having not touched any of these code bases or WebAssembly at all. So everyone's help has been really, really incredible, especially Alex, who's reviewed pretty much every single one of my pull requests for all of this stuff and been very patient in explaining all this stuff to me. So yeah, thanks to everyone who has given me a hand with this, and I will take any questions.
Yes, thank you so much, Sai. There was one question in the Zulip chat so far from Mindy asking, the JS event loop basically does cooperative threads, right? And Till already gave an answer. Not entirely, no. JS doesn't have the ability to suspend entire stacks instead of single frames for async functions. So if you need to suspend an entire call stack, you have to build that in content yourself. JSPI does integrate stack suspension for WASM into the JS event loop. Inside, if you had more to add on to that, you're absolutely welcome to. But otherwise,
no, like I said, the whole JSPI JCO part is not my area of expertise yet. So
absolutely fair. Joel has a question.
Hi, thank you. Sai, first of all, thank you so much for this awesome work. I'm super excited about it. Regarding WASI libc and pthread support, I wondered if you've thought yet and how you're thinking, if so, how you're thinking about blocking POSIX called like read and write and that sort of thing, and making sure that suspends the thread if necessary and whatnot. Have you thought at all about that?
Yeah, I haven't been looking at the that part of the API much. I know the Krzysztof Pettig has done a lot of work on the WASI P3 side of all of the stream writing and reading and things like that, and wants to be able to yeah, it would be nice if WASI libc, for example, exposed not only the blocking versions but also async versions that you can use if you know that you're using WASI libc on WASI P3 and have async support, then being able to use those explicitly would be nice. But then, yeah, we also need to make sure that the blocking ones actually do suspend you and get switched out. Yeah, it's not something that I've looked into much yet, but yeah, that's definitely something that's on the radar.
Sounds good. Thanks.
Any other questions? Anyone on YouTube, please use that Zulip topic to add your questions. Anyone here on Zoom is more than welcome to come off of mute and ask one. I've got a question from Alex.
Yeah, so I wanted to ask a little bit about I shared everything threads from the browser perspective in terms of how that relates to all this. So I know that I mean I I suspect this will probably come up, and so I'm wondering have you, Sai, or I think Luke, have y'all given a little bit more thought to this? I know that we have kind of rough ideas, and I know shared everything threads is not finalized for kind of the multi-threading case inside of linear memory. It's kind of mostly focused on shared GC objects right now, but any further thinking or anything we want to kind of like put on the record here in that regard?
Do you want to take that one, Luke?
Sure. Yeah, the idea, in fact, the genesis of all of this context.get and thread new and direct, a lot of these primitives actually came from an idea from Conrad Rott, which was if we can think of all the stuff we're doing now as paving the way for shared everything threads and saying all these primitives, once we have the ability to put shared on core functions, which means it can run on any thread preemptively, all these built-ins we have, the ABI changes of calling context.get and set, to access TLS and all those things, we've already done a lot of the hard tool chain work to use them. We'll just put shared on them, and then a lot of things will mostly work. Some things will need to change a little bit, like we'll need to be a little more careful with atomics around synchronization primitives. A few targeted places will need to change to handle actual preemptive threading, but a lot of the heavy lifting will already be done. So we're kind of making the big leap away from, just use globals, like that big leap. And also let's think about TLS and stuff. So hopefully we're taking ourselves kind of far along a lot of the way there, so that when it's time, when a lot of this stuff, the dust settles and it lands, someone's going to need to lead the charge on shared functions. Shared everything threads, the linear memory version, not the GC version, because it's a lot of work, and hopefully we'll have done a lot of that work such that to do an experiment to build a working prototype of preemptive threads, it won't be super hard after all this cooperative threading is done. So we have given a lot of thought to it. And also Oscar Ryan Hunt's also keenly paying attention to just exactly this topic as of late. So it's going to get a lot more scrutiny over the next 6 months.
Yeah, I'll say from like the WASI-libc perspective, all of the pthread stuff that was in there existing was based on muscle libc implementation and has all of the kind of internal synchronization stuff already there. So while implementing the cooperative threading part of it, some of that is needed, some of that is not needed, because of course if you're going to be holding a lock over context switch, then you need to have the lock. But if you're not going to be doing any context switching, then you can just completely get rid of it. But I've tried to maintain all of the structure of the synchronization code such that as we get towards preemptive multi-threading, then it's we don't need to add any of that stuff back in. We just kind of switch a flag and it all just works.
There's another question for you, Sai, from the Zulip chat. Are there places that folks can start on work, like for the guest languages? Is it about ready for that?
I think if you want to play around with guest language stuff, you absolutely can. I think at this stage you'd probably just have to talk to me and I can give you the branch names, and then you have to build LLVM and WASI-libc from source. I'm hoping that the two-phase experimental thing will ease that somewhat. So at some point you'll only need to build WASI-libc, and then at some point you'll just need to grab the experimental toolchain and it should be okay. But if you want to start work on guest language support tomorrow, then yeah, let me know and I can help you get set up with a toolchain.
Excellent. Also in the chat, Joel notes that he's expecting WASI-libc pthread support will be the foundation for most guest toolchains. That is, those toolchains will need to wait for at least an experimental thread-enabled WASI SDK release. Bailey extended on that, asking is that roughly how Rust will work, and shouted out to some work that Joel had done. Joel said yes, WASI-libc first, then Rust standard, then Tokyo, etc. Then Till said for preemptively scheduled parallel multi-threading, there's a proposal and a paper that are relevant, which you can see if you go check out the Zulip topic. Any other questions for Sai? All right, folks, that means that you've earned a 5-minute break. Myself will be going in and grabbing another seltzer. I got to stay hydrated throughout all this excitement. But we'll catch you all back in 5 minutes for discussion on the tooling roadmap with Alex. So see you all in 5 minutes. Bailey, we got any music we can play while we're waiting for 5 minutes?
It's a great question, Oscar. No, well, I mean, I know where you can grab your seltzers, which is directly behind you. So maybe we just sit here and entertain the people.
My fridge is empty right now because I drank all of them and I've been too lazy to put more in there. So the only thing I have in there right now is a beer, and I don't know if we want me, getting started right now.
Yeah, I know where you are in the world, and it is a little early for that, but it
Nah,
is,
it's
as
past
they
noon.
say, 5 o'clock somewhere. So,
Oh yes.
if we could throw up the slides for the agenda just so folks can see where we are, that'd probably be a good thing to do.
I can absolutely do that.
Sweet. I know that I made that slide, but I've lost it, which is an impressive ability I have.
All right. That's not the agenda. There we go. All right. Well, I was not joking. I am going to go get a seltzer,
Okay,
so I will be back.
This is good.
All right, folks, I know you've missed me all just dearly. But I am pleased to announce that I did acquire a seltzer. It is a ruby red tangerine flavor, and I encourage everyone to grab their own water beverage as well.
I was wondering, Oscar, I'm actually not sure I've shared from this computer before, so can I share my slides and make sure that double check that works real quick?
You absolutely can.
Hey, it does work.
It works.
I'll just leave it here then.
What languages don't require WASI-libc?
Go.
Oh, thank you. Let's go, Joel.
Real ones.
Kotlin.
Yeah, I was thinking Kotlin as well.
I did
Yeah.
see Zalim. Zalim, did you hear that?
I expect Moonbit, but I'm not sure.
But all right, folks, break time is over. We're back on WebAssembly. And with that, we're going to kick it off with the discussion on the component model tooling roadmap led by Alex Crichton. The way this is going to work, if you're on the YouTube stream, post any questions or comments you have in Zulip, and I will be here and channel your inner voice to Alex and everyone else here. Folks, if you're on the Zoom call, you will be welcome to unmute and engage in the discussion. But Alex will first give us some guidance before we get going. And with that, Alex, off to you.
Thank you so much. So yeah, this is going to be kind of a high-level description of roadmap-ish, discussion-ish, kind of a little more details than what Luke and Sai have already been talking about. I definitely plan on, people can definitely raise your hand or ask questions in the middle. We'll kind of see how this goes. So to start off, I kind of want to give a bit of an overview of the precise tooling that we have today. Kind of these are sort of the injection points that we as designers or kind of shepherds of the component model have to kind of leverage and have to kind of manipulate here. So a lot of integrations typically start with WIT, as we have seen, and then this is where a tool like WIT bindgen is going to come in, which will actually generate some sort of guest language binding. So we have this, for example, for Rust and Go and C. But this also exists in terms of other languages, and I'll kind of explain that in a little bit. But the general idea is there's some form of take the WIT, generate some sort of guest language stuff, and get bindings from there. A lot of times this will then involve some sort of compiler, which then generates a core assembly module. And the reason I want to call this out is that we don't currently have any compilers that natively emit a component. So everything is still talking about core WASM under the hood, which means that this is sort of the primitive that we are building on. This is kind of the reason for the C ABI that Luke was talking about, kind of those header file ideas and kind of all the discussions we've had about ABIs. This is actually what toolchains are emitting that we have to deal with. Now, the actual way to actually create components, this is from WIT component inside of the WASM tools repository, and almost everything goes through this. So, and the unit of the primitive to be operating on here is that there is a core module coming in. It's got some metadata attached to it, embedded within it, and that is used to actually create the component itself as a result. And then after that, we get to do all sorts of kind of standard tooling. We can whack between multiple components to make more components. We can take components and run them in WASM time. WASM time is then also heavily based on the actual WITs that you were originally generating from with a guest language. This is sort of like the shared point between. This is sort of generating bindings in WASM time. This is where the WASI creates come from. This is where all the bindings come from, and yada yada. And then finally, we have Jacob here as well. That is, for example, an alternative runtime where you can kind of take this component and run it in multiple places. So the general experience, though, is folks don't actually go through every single one of these boxes. We tend to want to bundle these up into kind of one command. So for example, in Rust, you just say build with a particular target. You can use a targeted compiler with Clang, and then run all this inside of WASM time. And again, I'm saying that this is sort of the high level idea. Oh, yes. Oh, so this is sort of the high level idea of kind of how these are all going together. But each toolchain is a little bit different. So for example, in Rust, we have sort of this generate macro with the WIT bindgen crate, and we go straight to the component with the WASM32 target. Under the hood, it's still doing the core WASM thing, the WIT component thing with WASM tools or WASM component LD. But we have other examples. So for example, the Go toolchain will actually be a little bit more literally like this, where right now Go still emits a core WASM module, and the WIT bindgen Go is literally generating Go source code that you are including. But componentized Pi is totally different. At componentized Pi, the tool just bulldozes all of these and goes straight to a WebAssembly component after ingesting both WIT and Python at the same time. But again, under the hood, this is kind of all what's happening. Like Python itself was compiled with C, it's got a bunch of core modules, all of that's thrown together in WIT component, all that fun stuff. So the other aspect that I want to highlight here is that we don't, as the Bytecode Alliance, have necessarily control or shepherd all of these dependencies. So we do have we do actually shepherd a lot of it, things like WIT bindgen or Jaco or WASM time and the WIT component tooling. But there are very much aspects that are outside of our control or outside of our kind of what we are deciding. So for example, the Rust programming language has its own release cadence. LLVM has its own release cadence. Python has its own decision about whether it even wants a WASI target, things like that. So we are operating in this space where we are sort of kind of layers around the tooling, and we have some injection points that we have a lot of leverage and control over, but we are operating within the context of other languages and other ecosystems that have their own priorities, their own release maps, and that's something we have to be cognizant of, and it's kind of how we frame our discussions to this and everything like that. So a lot of what Luke has been talking about is sort of the new features that we want to bring to the component model leading up to 1.0. And so a lot of this talk, I want to kind of focus on how exactly we've been thinking about those and sort of a little bit of a roadmap of how we can be implementing those kind of at a little bit of a finer grain detail, sort of. So the first thing that I want to go over is sort of the principles to think about with new features in the component model. So this is one where the general idea is we are in a preview stage. We call this WASI P1, P2, P3 for preview 1.1, whatever you want to call it. But we are not in a privileged position of just breaking everything. We actually have a lot of users. We actually have a lot of folks using all of this. So we don't have options available to us where we can just change everything and break everything on a whim. We have to do this in a way where all previous features and components and everything continue working. Luke already mentioned this, but I definitely want to emphasize this aspect of all of this is effectively stable, and we have to operate as if everything we've done is effectively stable. And we're designing for a future where we can eventually ignore this stuff, but we have to assume that all of it has to continue working in the meantime and have migration paths and such. The other aspect here is that from a development perspective, we very much need to ensure that the final WASI 1.0 and component model 1.0 is a subset of whatever you happen to be able to do with WASI P3 at the time we cut that off. So it's not today's WASI P3 because we're currently missing co-op threads and things like that, which we obviously want, but also all the features that Luke was mentioning. But this is a very key, important aspect of the development cycle in the sense that we can't stamp something that we've never tested before. We can't stamp something that's not actually integrated everywhere because we need to get implementation feedback. We need to make sure it actually works. And so that's the aspect here. We need to have, the goal is to have a subset of the final development of WASI P3, and then that is what is stamped as WASI 1.0. That's what browsers in theory would be trying to implement, or the runtimes would be trying to implement. And so Wasmtime is kind of the most burdened here, where Wasmtime, as sort of the pioneer of the component model, we're going to have to keep all this historical baggage for a while, but other runtimes may not have this. And this also matters from a guest toolchain perspective, where the vision we have for a component model 1.0, if a toolchain is relying on a feature that is not part of that, but is in WASI P3, that is a bug, and we need to fix that. That is a priority of, we need to shift all toolchain development over time as it's appropriate to the subset that will become component model 1.0. We can't be relying on things accidentally that we haven't actually shipped just yet. This is, I have already mentioned this, but basically we need to be able to produce what looks like the WASI 1.1.0 component right before a release. So you can imagine that I could, if I turn on a validation predicate where I say turn off all the WASI P3 features that are not going to become 1.0, we have to be able to produce that component ahead of time. This is, again, critical for testing, critical for making sure this all is actually integrated, and make sure this actually integrates into all the ecosystems very well. Another aspect is, so we don't control things like Rust or C or Python or anything like that, but we need to be doing all those development upstream in those ecosystems. We cannot have a bunch of forks, a bunch of libraries, and call that this is WASI 1.0 compatible. We actually have to do a legwork ahead of time, and this will delay a lot of roadmaps. This will delay a lot of times because it takes a large amount of effort and kind of working to get all this upstream. But anyway, that's sort of, we want to focus on upstream development. We want to focus on kind of engaging with other ecosystems, and if there are concerns, we have to address those and work with those and all that fun stuff. And I know Luke was mentioning that we probably want to sort of auto-convert existing components to WASI 1.0. I think that's kind of a reach goal. We very much do want that, but exactly how this is going to work, how difficult it is, how viable it is going to depend on the decisions we make along the way, how far along toolchains are, how many components we have to migrate. So we'll kind of see this over time. So, okay, the next thing I want to talk about is sort of a general roadmap for how these features are going to be implemented. This is kind of a lot of what Luke was describing will fall into this sort of bucket. And this is kind of a little bit of an answer to what Bailey was asking of how folks can be injected. So the high level idea is, first you start with a specification. This is the component model repository. It has the canonical ABI.md and explainer.md. This is not kind of like mathematical formal semantics quite just yet. It's still mostly English prose in terms of formal semantics, but the idea is we get agreement on what we're going towards, but not necessarily the perfect details just yet. Typically, what follows on next is that this is then implemented inside of WASM tools. This is sort of the binary format, the text format, the validation, and also where we start to actually create components, where you can write raw textual components and create components, but it's not particularly usable just yet because we don't have guest language integration. But the general idea is this is a feedback loop where this starts providing feedback to specification, which then starts going and updating as well. And so once WASM tools is then done, we tend to start implementing things in WASM time. This is the runtime side of things, runtime semantics. We get some tests, we flesh out the embedder API, all the various things there. And again, this is another feedback loop, which feeds back into the whole process. And then one of the later steps is the whole with bindgen integration of this is kind of, again, not literally with bindgen per se, but sort of language integration where we actually start being able to write code that is in C or Rust or Python or whatever. And we can actually use this feature. We can actually write some tests in that, get the whole end-to-end testing through WASM time, through these languages. And often that does happen in the with bindgen repository for at least the initial steps with Rust. And then the final step, which kind of sometimes is a little broken out of this feedback loop, is guest libraries and guest toolchains. So for example, Joel's work recently to get YZP2 support in Mio, that was involving getting a lot of support in YZLibC, then getting that into Mio, kind of working with the constraints there. But there is a lot of work to be done in terms of getting this into not just WASM time or component model specific things, but also kind of integrated nicely into particular languages. So there's a number of gotchas I do want to highlight in terms of implementing all these sorts of features. One is obviously the initial design is very rarely the final design. For example, we actually had async in YZP2, but we decided to defer it, and it was nowhere near as good as it actually currently is because we actually had time to focus on it. But just the general idea is all of this should be expected that whatever we come forth with, it should be an expectation that that will actually change. It will not be the final design. It will require some tweaks over time. Kind of depends on the feature. Another aspect is that reviewer bandwidth is often one of the major limiting factors in all of these features. This is not just on the spec side or on the Bytecode Alliance side or on the WASM tools side, but this is also on the upstream side. So engaging other ecosystems and trying to get reviews from them, trying to engage, and this isn't just literal code review, but also sort of design review and sort of ideas there and kind of the thrust of WASI and everything. That can take a lot of time. So we definitely need to make sure to budget a fair amount of time in that regard to make sure that this is taken into account. Another aspect is there's a lot of stuff here, especially like, for example, component or API design in WASM time, which doesn't really have a lot of precedent. So we didn't really know what to do with this accessor type or run concurrent type. Or I would also say that WASM GC support was very much in this bucket for WASM time. It was kind of a little unclear of how to write a GC API inside of Rust, which doesn't have a GC. And so this is something to budget for, something that can have a lot of gotchas of when an initial feature comes into WASM time, we're not quite sure how to shape it, or maybe how do we exactly expose. I mean, threads are a little more direct, but like the map type, map of KV in WIT. How exactly do we do that in JavaScript or in Python or in Rust, and mapping all of those down? There can be interesting questions there, so there can be some roadblocks or some various gotchas like that. And then finally, there's a lot of release cycles we need to manage. And so, for example, we've got Bytecode Alliance projects that we generally control. We can kind of do on demand, but LLVM, for example, is once every 6 months. Rust, once you land something, is about 9 weeks to become stable. User libraries have their own various things. So, example, like for the Mio or Tokyo crates, their own release cycles. So this is very much a concern in terms of if we want to plan all these out, we have to line everything up and kind of consider all of this to make sure that we're kind of landing in a spot where we can land changes. We can eventually get to testing these changes, but it all takes that into account. And then finally, the final gotcha is that bugs here can be sort of, unfortunately, very disruptive in terms of if we rely on a bug fix in LLVM, if it requires like bigger factorings, that kind of delays everything by about 6 months. If backporting is not a possible thing, or kind of backporting can require a lot of engaging of the process ahead of time. So this is where we very much want to kind of have this all as fleshed out as possible at each step along the way. This is kind of thorough testing, thorough as much as we can, the fuzzing aspect, kind of basically this is just something to keep in mind of if a bug appears, what's the process going to be like for how do we actually push through that bug, fix that bug, and get that through. Okay, so the final aspect I want to talk about in terms of new features is sort of this high-level concept of versioning, which we haven't really touched too much on. So as Luke had been mentioning as how we can actually separate is the component model is distinct from WASI. So component model doesn't have versions right now, but WASI does have versions. But I would also say that for all intents and purposes, practically these actually are pretty much the same, and where WASI 0.3's flagship feature is async, and that's also the component model's flagship edition at that time. So what I'm kind of saying is that while WASI hasn't had version and component, or WASI has had versions and the component model hasn't had versions, I think we kind of want to consider the component model as being versioned somewhat alongside WASI, maybe in lockstep for now to make sure we don't have too many versions in play. But the general idea here is that eventually these will start diverging. But for the meantime, on the development stage, I think it'll be kind of reasonable to say that we can say there's a particular snapshot of the component model repository, the component model specification, which we can say that this is 037 at the time, and this particular component validates with that. And this would be similar for WASM time, of the feature flag would say I would like to turn on some particular feature. This is a proposal. We have a little bit of bike sharing to do here, but the general idea is that this is providing a set of shared terminology by which we can all talk about component model features, component model versioning, WASI features, and things like that. What this is more or less in theory boiling down to is that let's say we add co-op threads. Let's say that the next WASI release is O.3.3. I think what we would kind of want to say is that while that co-op threads is not affecting the wits in any particular way, I think a WASI we want to push for saying a O.3.3 compatible runtime does have support for ungated threads or ungated co-op threads. That'd be kind of an example. Let's kind of push through that. So there's still, we need to have a lot of discussions about this, especially in sort of a standards venue, standards forum. But I think we do want to sort of consider this of, as we add these features, we still want a sort of discrete step along the way of this particular WASI version is now going to assume that you have the previous component model features that are done and have some sort of like marching forward. So, okay, any questions or anything? Anyone want to say anything before the next steps where I talk about some more specific features? All right.
There are no questions in Zulip yet.
Sounds good. So, okay, I want to sort of categorize some of the features that Luke has been talking about and also sort of categorize how at least I personally feel about them. So I would put these in various buckets of small, I think I'm going to say, let's see, less small and not small. I was going to put it up here. So small features, I would consider this list error context, optional imports. A lot of this is, there's not too many open questions in terms of the spec design or the guest language design. It's relatively straightforward. We kind of generally know what we're doing. We kind of generally, it's pretty well defined. It's unlikely to have too much feedback in that feedback loop. And so a lot of these are pretty easy to get started. This is the following that standard specification, WASM tools, or WASM time, WIT bindgen, kind of blow through all those. There's lots of stuff, context in each of those projects. Each of these features will touch different portions, but the general idea is a well-motivated individual can make some good progress on these modulus, on those gotchas I was mentioning in terms of like reviewer bandwidth or timelines up through projects, things like that. Some of the less small features, this is where the exact design is a little bit less clear. So we don't exactly know exactly what the GC ABI option is going to be. There's some questions about how exactly would variants look? How exactly would the intrinsic look? Or maybe this is blocked, for example, on the lazy ABI changes of how exactly would the lazy ABI stuff look with GC ABI? So a little bit more of an open question there. But I still say they're somewhat small in the sense that they don't have a massive impact on their runtime necessarily or on kind of new foundational features for languages. So, for example, callbacks are kind of going to unlock the ability to write callbacky looking code inside of a guest language, but you just can't do that today. And so it's not sort of changing what you're currently doing. This is in contrast to these sort of not small, very large features, which are massively changing what you're currently doing today. So all of the ABI changes affect basically every single tool we've ever written for the component model. So if we want to change with lazy ABI or the C header idea or changing the literal ABI or taking advantage of multi-return, all of that is going to touch every single tool everywhere. Will take a very large amount of time and effort to push through at the same time for all of these. And co-op threads is similar where it's sort of unlocking code you can write today, but it's a very large shift of everyone has assumed threads don't work and every library needs support for that to now it actually all of a sudden does work. So I guess I've sort of already kind of dived into a lot of all this stuff, but like for example, a lot of the ABI stuff will require touching LVM. This is where this dependency chain goes pretty deep. LVM doesn't really have support for multi-returns right now, especially at like the C or the Rust level. Kind of at the IR level, there's a bit of support. We still haven't figured out what exactly the C ABI is going to be. And if we change it, it's a little unclear how we're going to change that because then you have stuff that used it beforehand, stuff that used it afterwards. And then the aspect of ABI I've been mentioning that the final snapshot for WASI 1.0 is a subset of what WASI 0.3 supports. So we probably need some sort of, the ABI is so fundamental, we need some sort of tool to effectively translate today's components to the lazy ABI components. And that's a pretty big project inside of WIT component. And then co-op threads and streams kind of have a lot of aspects, especially streams in terms of mapping into various languages. Co-op threads, just from the implementation perspective, we've already seen, Joel was mentioning, we have to work through, or Joel and Sai, to implement this in WASI-libc, plumb that through a lot of tool chains, get that in Rust, get all the testing there. And writing a threading library is no small feat. There's a lot of features going on there. So I want to give a bit of example of sort of one way to think about all of this in terms of kind of decoupling things versus the hazards of coupling things. So let's talk about just the ABI changes and some dependencies involved here. So first we can follow what I was saying earlier of the standard thing of if we want to change the ABI, we specify it, we implement it in WASM tools, WASM times, and WIT bindgen. So we've got all that done. However, we can't actually do the WIT bindgen support because part of the ABI changes is using multi-return. But so we don't even have support for doing that in Rust. So we can't even actually do that in the Rust generator, for example. We might be able to do it in C, but also C doesn't exist. So we also have to do that in LLVM and specify what does it mean to do it in C. So now that's dependent on that. And because the Rust side is dependent on the LLVM side in terms of Rust doesn't really want to invent a new ABI. It's kind of, we have to invent the ABI and then tell everyone exactly what to do. But then that's also dependent on what exactly is this C API, or what exactly is this header file looking like in terms of how many return values do you get, or what exactly are we actually translating this to in the in-memory representation. And so that's all dependent on the spec. And so we all of a sudden, if we try to do all of this at once, we have all of these sort of interlocking dependencies, which are a little difficult to make progress on because there's not a lot of opportunities for a feedback loop here where if it's kind of LVM is in the middle or all these upstream tool chains are in the middle, it's difficult to kind of do that and make progress. And then when we finally get around to this WIT component rewrite, which then actually takes the existing components and rewrites it to use this new component, we'll find out that kind of these are actually major projects, kind of WASM time implementing and supporting multiple ABIs, with bindgen supporting multiple ABIs, with components supporting multiple ABIs. Add into the fact that LLVM's release cycle is quite slow. Rust's release cycle is then delayed after LLVM's release cycle and is also 9 to 12 weeks. We get into the kind of this morass of there's just a lot of stuff tied up here. So this is, I think, an example of if we try and lump too many things together, we're going to kind of have a bad time. This will end up kind of artificially delaying things, artificially kind of making things, pushing things down the road, largely for things outside of our control in terms of like the LLVM and Rust and upstream release processes. So instead, what I'm basically, I think we should push for is to try and separate things out as much as possible. So have lazy lowering be entirely independent of multi-return, which is entirely independent of a new API, which will line up exactly with what the C API defines. This does mean that multi-return, for example, still has a bit more of a large release cycle because that is affected by LLVM. However, this is one where it's a little bit more clear in the design. So right now we have this limit in the ABI saying you can have one return value, and the implementation of switching that would be turn that to 16 or turn that to some other value. And so it's relatively obvious from that perspective of what the spec changes are. So the spec is kind of much easier here. Anyway, my point generally being that this is an example of we want to split all of this up as much as possible, keep this all as parallelizable as much as possible, and this will increase the maintainership burden. This will increase the sort of implementation burden, but I think it's sort of, this is kind of what we need to push these features and actually get them all landed roughly at the same time on the WASI 1.0 or component model 1.0 timeframe. Okay, so a few final things. I don't want to take too much longer. Is I want to give a bit of an overview of what WASI is today. So today, all testing of WASI P3 is actually going through WASI P2, and then that happens to also import O.3. So we don't actually have the WASI P3 targets just yet. C and Rust exist, but neither of them are shipping. A lot of this needs to work in WASI-libc, the primary dependency point. So if you're interested in helping out, that's kind of a primary point of getting WASI-libc up and running. Then we can propagate that to WASI SDK and Rust. There's a lot of ecosystem integration work independent of WASI P3, but also with WASI P2. So for example, this is Joel's work inside of Mio and also getting this inside of Tokyo, but the further extent of getting component model level async integrated into language level async is still going to be an ongoing question. For example, Tokyo it's an open question of how to integrate the component model level async into Tokyo. And then there's a few more final aspects of WASM times component model async implementation. We've been discovering a steady trickle of panic server development, so we definitely need to be working on the fuzzing and testing story there. And then kind of Sai alluded to this with the threading aspect, but there are certain performance profiles that might need some work depending on if downstream embedders actually end up hitting these cases. So, for example, composition is going to become a little bit slower in the sync-to-sync case when concurrency is enabled. Things like that. If that is a priority today, it means that we have some performance work to do. But otherwise, the performance that we have done is kind of like HTTP performs just fine, and all that performs as expected. So that's sort of the general ish for where WYSIWYG 3 is today and kind of where it needs to go. So, okay, this is kind of this has been a little bit meandering, but this is sort of the summary aspect, which is that so I do want to emphasize that a lot of the features we have are parallelizable, modular the whole human aspect of reviewing and implementation work and all that. We very much want to keep it that way. So, for example, the ABI changes, I think we need to make sure those are nice and split up and parallelizable as much as they possibly can be. I do think we want to start shifting towards a model of WASI 0.3.x is saying that a feature is ready, and that we would say that runtimes only advertise as supporting this unless they support that feature. And then languages, when they upgrade to that WASI version, they can say that they now require runtimes that have that feature, or they can assume that feature exists. All this upstream work instead of LVM, Rust, and various other upstream crates and libraries, or just any language ecosystem, we always need to prioritize getting that as soon as possible in pipelines because of various timelines there. And yeah, so okay, the other aspect I do really very much want to emphasize is that I've been talking a lot about various features here, but kind of from the WASI 3 aspect and kind of maintenance aspect, a lot of this is going to be pushing forward the component model exactly as is today with our continued maintenance, continued improvement, integration into ecosystems. So it won't all be necessarily focused on new features and things like that. It's also kind of pushing on the existing ecosystem in that respect. Okay, so I intended to leave more than 4 minutes for discussion, but this is these are the slides that I have, so I'm happy for discussion and questions now if folks have that.
So we will take some questions now, but in relation to the break that we have coming up in 4 minutes, it will be a bit of a water cooler session. So of course, it is going to be recorded and it'll be available afterwards. So if you need to take your break, absolutely. But otherwise, grab your water and join us around the water cooler as we continue talking about this. But yeah, if there's any questions, especially if you're on YouTube, please get them into Zulip and I'll relay them here. And folks, if you're on the call, feel free to unmute and let's get at it.
Wow, Alex, that was awesome. I'm a bit stunned, but would you mind, because I'm very selfish here, and would love for you to talk through one of the small, easy changes, concretely, like just put up a PR this morning in relation to issue 287. That's the implements with parameters. What would be your ideal process for the next step after that? I think from your slides, and you had a really great flow diagram if you want to speak to that. But essentially, I think the next place would be to talk about kind of a sketch and an issue in WASM tools. Or would you prefer to collaborate around code, like put up a draft that's like, this is sort of the idea here?
No, that's a really good question, and this is one where it's not really, it kind of depends on the exact feature per se. I think personally what I would say the best way to go is to have a PR on the component model repository exactly as is, and then leave that there. So don't merge it, but kind of have that being a living document in the PR. And then we have a second PR inside of WASM tools, which is kind of the discussion around that, where I find personally, at least, that the actual code implementation will very heavily inform discussions around this. It kind of makes things concrete, makes it so we're not talking a lot less in hypotheticals, but it's like I ran this tool and I have the test. And so for this WIT feature specifically, I expect that one of the biggest things here is going to be the design around WIT, the design around encoding and serialization, and kind of getting all this fleshed out inside of WIT itself. And so the WASM tools side is probably going to be the biggest one. And so thankfully that's kind of the tightest feedback loop of those two. And so that's what I recommend is having the spec PR open, having the WASM tools PR open. And those can probably land simultaneously once we're kind of pretty comfortable with all those. And then for that specifically, I expect the WASM time and the WIT binding implementations would be relatively simple to follow on afterwards. But I can actually speak. Luke also mentioned this, but Yordis has been doing fantastic work for map of KV, and so he's already got some PRs in terms of the specification, then the WASM tools, and there's a WASM time PR open, and that I can I'll link those in Zulip afterwards. And that's a great roadmap. Those have been going really well so far, in my opinion, in terms of having like this sequence of implementation steps and kind of handling all the gotchas and getting a lot of tests as well along the way before we get to, and then Bytecode would be the next step there.
Yeah, and the other shout out there for Yordis is that he's a new contributor in many of those projects. And I agree. It seems like that's been, from the outside looking in, looks like that's been going great. I bet he wishes he had this presentation before he started, but yeah, awesome. Thank you.
The water cooler is here, folks. You are more than welcome to chime in. We're all friends here in the BA. I mean, we're literally an alliance, folks. Like, you can get in here. Question. When will we opt to break apart WASI and component model versions? Right now, coupled to decrease release, maintainer stability, and overhead.
I think personally, I would probably say once we're more ready for the phase 4 style stuff for the component model. And so I think that would sort of be that we're still pretty far away from that branching point, but I think we would probably branch to like some 1.0 RCs around that time for the component model. And then WASI itself would continue to evolve with its own WIT APIs. And I think the rough expectation around that point is we would fork a 1.0 RC. That would delete a lot of stuff in WASI P3 that we do not want. That would clean up the binary encoding. That would be kind of like shuffling a whole bunch of stuff. And then that is the target for browsers. That is the target for kind of runtimes that don't want all this historical baggage. And then all WASI development assumes that's all we got.
Got it. Joel.
This one's for Luke, or not, sorry, not for Luke, for Alex. I was a little surprised to see that you included optional imports as a small project. I felt like in the past we've discussed it and it felt like it was going to touch a lot of things. And I think you've posted some issues that I maybe need to just review. So just you feel free to tell me to just go back to that. But I'm just curious how you're thinking about it now and why you feel it's small.
This is actually a very important caveat. I say small here. All the floor for small is actually still non-trivial. So I don't think any of these are like a weekend project. A lot of these are still pretty significant in terms of implementation. So I would answer your question of, I actually still think that optional imports is more or less the same amount of effort as it was beforehand. But I think I'm describing it, I guess, small relative to some of these other changes. And small in the sense of like it's an extension of the component model, which is it's sort of the smallest possible extension of the component model in that sense, where it's like a nice localized feature that doesn't affect too many other things. But it is actually really important to call out of a lot of this does require relatively significant investment in terms of there's a lot of code bases to get into, a lot of reviews to be had, a lot of language integration aspects to be thought of. And for example, with optional imports, I think it's relatively straightforward. So we'll have some sort of WIT bindgen option that C is optional, and you get some sort of optional stuff in Rust, for example, or nullable pointers in C, or things that are just none inside of Python, yada yada. But doing a lot of that work, doing all that plumbing is still relatively non-trivial. And so I'm saying small from the number of open questions perspective and kind of the number of things we just don't know and how much that feedback loop is going to be required versus how just you can just do it and just go straight forward to the bottom.
Yeah, I guess I was feeling like there were still some open questions, like if we were, because at one point we were talking about doing sort of like a contained version that wasn't the whole version, and then are you so and I'm still not 100% clear on like, and maybe I just need to go back and look at the GitHub issue, but on it felt like there were still some open questions, but maybe those have been resolved.
No. That's a good point. And this is one where I think for optional imports specifically, we sort of had the idea of we might want to ship kind of a halfway thing, which is like not the full thing, but halfway, but like just the not integrated with the component model, but just the tool chain. And I think we've more or less sort of acknowledged at that point that's probably just a bad idea, and I don't think it's going to work. So we haven't actually done that work, and so I think we've decided that that branch of work is more or less just dead, and we actually need to just integrate it into the component model and go that route instead.
Sounds good. Thanks.
We've got another question from Bailey in the Zulip chat. Where is map in this iteration / feedback process? What will be the point where we say it's shipped?
I would say that map, or wait a minute, I'm going backwards. I think map is at the Wasm stage just now, so it's done. So we've got the spec for it. We have the Wasm tools integration, and then Wasm time work is ongoing, and the next steps would be wait bind gen and then pulling that into various APIs as necessary. The second question here is kind of the shipping aspect. That's actually a really interesting question where I haven't really touched too much on that, but the general idea is kind of what I would like to consider this is that at some point we as the subgroup, or I suppose we as participants of the subgroup, and then we as participants in the standardization process for the component model, everyone will decide it's done, we're happy with it, and the next version of WASI has it ungated. And that would be whatever version of Wasm time that happens to be in, we would ungate that. So leading up to that point, it requires opt-ins, gates, no one can use it by default. And then that decision point is where we say, all right, let's turn it on. And WASI itself may not use the map type just yet. Like maybe there's not some new API using it, but part of that release would be embedders and languages and things can now start using this.
Victor.
Hey, can y'all, you may not be able to see me.
Can't see you, but we can hear you.
Okay, great. So you should be able to hear me now. I didn't see me. So I wanted to ask if there's any sort of appetite around reorganizing the canonical ABI documentation. So this is the stuff that basically is in the component model repo into sort of stages. Let's say like across, let's say P2 features, P3 features, and then all these features that are coming now. Because looking as a sort of implementer or anyone who might look to try and sort of build all of the sort of machinery that we've essentially worked our way up to, it's really daunting to look at a massive list of essentially built-ins that you need to support. And ideally, anyone who's looking to implement the component model is from a host point of view, should be able to sort of step through features, right? So like, let's say, implement resources and then implement context, let's say, and then implement sort of back pressure, or at least as far as things can be sort of broken apart and thought of individually. And it'd be nice if that was sort of reflected in the sort of organization rather than necessarily one massive document.
We do have emoji gates that tag things. You can search for the emoji and that kind of slows you slices. And as we add new features, each one will have an emoji gate. I've also thought the lazy ABI will take a lot of stuff that's in the canonical ABI and delete it. If you only support the lazy ABI, you just didn't have to read that stuff. So I have thought about maybe just to make it less daunting and to strip some of the scarier parts, particularly the auto back pressure and the string transcoding that I mentioned, to maybe make a copy of the documents, or maybe, I don't know if Markdown has like a little collapsible things, make things hidden by default.
It does. Supports
yeah,
the
so I was
summary.
hoping it did because it 2 documents seems like it suck. But so have the stuff that you don't have to care about if you're going straight and only to lazy, auto hidden by default, and so that would be a thing specifically to, so so that's something. But yeah, I guess all future features, since we emoji gate them, we have this kind of an official process, or kind of official process of emoji gating each new edition. Everything going forward is going to have one. There's one big emoji gate for like all of async. I guess it could be subdivided if we wanted to talk separate context.get, but a lot of the other stuff's all kind of in one group, which is doing async, which is all has that async emoji. Yeah, we can talk about that, particularly once we do lazy. I think there'll be a refactoring appropriate.
The one thing I would add on to that is that I think the smashing tool that Luke was mentioning is actually going to be really, really helpful here, in the sense that if you produce a component that only talks with integers, you would expect that the final component doesn't actually use a lot of intrinsics. It would only talk about integers. And so I think it's sort of our responsibility as sort of toolchain maintainers to say that if you produce a minimal looking component, it actually uses as few features as possible. And then that smasher would produce a thing that doesn't actually import a bunch of intrinsics. It would only talk about a few particular types. The rough idea there being that you could take test cases at a time, and you could you could start importing this component. You could panic on everything you don't actually care about or you don't actually understand just yet, and kind of incrementally work in that regard. Sort of work from a small feature set up to a larger feature set. And I say the smasher thingy specifically in the sense that like that boils away all the component model aliasing and instantiation and yada yada. You just get the core module aspect, which I think is a lot of folks will resonate with a lot better in terms of understanding.
Cool. Thank you.
So I see. Oh, go ahead.
Yeah, just a question that we got in the Zoom chat, which I appreciate was being actively moved to Zulip, but we're still going to address it live because this is a water cooler, baby. We can talk about anything we want. What are the plans around exception handling and garbage collection WASM time? When can we expect them to be tier 1 on by default? When, and I want to know this too. So, what's up?
I can give my own thoughts, although Nick, I assume you're on the call, and you can also jump in as well. So right now, the major thing blocking, or rather for WASM time, the only blocker for exception handling is fuzzing. We don't have a tailor-written fuzzer for exception handling, and we just once we get that online, then WASM times basically all of our requirements are met, and we would turn that on by default. For GC, I think it's similar-ish, where fuzzing is sort of a major missing aspect, but that's been worked on, I believe, very actively by Khan with Nick. And then the other aspect for GC is the C API. So we don't have any support in WASM time C API for that. That's a major missing piece. So I guess the way I would phrase it as there are technical blockers inside of WASM time's release process, or kind of our own feature requirements or requirements for turning features on by default that we haven't met just yet with those two. They're relatively straightforward in terms of what they are. And then in terms of timeline, I think it's mostly waiting on a developer / maintainer to be sufficiently motivated to actually perform that. I think that just hasn't happened yet. So as things progress, like like there's been a lot of activity and interest in C++ exceptions, and I think that'll be that is a forcing function for getting fuzzing done for exception handling and turning that on. And GC would be similar. So some language comes along, which would be motivating for a implementation here. But Chris or Nick, I don't know if you want to add anything else to that.
Go ahead, Nick, and then I'll add.
Okay. Yeah. So I also threw in Zulip the like WASM proposals documentation page that we have, which lists all of the actual blockers for kind of turning things on by default and the current status. The other thing is right now we have 2 collectors. We have a null collector, which will just allocate until you run out of space and then trap the program. And we have a deferred reference counting collector, which is a reference counting collector, and it does not have cycle collection. And so if you create cycles, they won't be collected until the store is collected. And that's fine for actually probably turning this on by default, I would think. But it's not probably what you want to use long term. And so we do have plans for a kind of semi-space copying collector, but in terms of prioritization of actually implementing that, for me personally, it's not clear when that would happen.
Yeah, and just to add a few more things, one minor detail, the C API for XNREST for exceptions is still not there yet either. So that needs to be in before we turn it on by default. And then the other thing is that, at least in the thinking around tiers of support, EH exception handling does use GC under the hood to allocate the exception objects. And so I have been under the impression that we sort of had this dependency reflected in the roadmap as well, right? So we can't turn EH into a tier 1 feature until GC is a tier 1 feature. But yeah, that can be discussed if pressure pushes us toward reconsidering.
I'm happy to pressure folks.
I would say, in my opinion, it's malleable. So I would say we would need to do some work, I think, to sever that dependence. But I do think we could get that work done inside of the engine.
Another thing for you, Alex. Bailey says, but exception handling is experimental in WASI-libc on LLVM patch. Will you share some status there?
I definitely will. But wait, Chris, sorry, did you have one more thing you wanted to add to that?
Yeah, sorry, I was going to ask Alex about what you just said. So you said sever the dependence, meaning an alternative implementation of exception objects that don't use GC under the hood?
I
Something else.
viewed it as more of a kind of an alternative collector, maybe a collector shaped, which is a little bit more appropriate for just this. But I think I was, but no. I would expect a relatively small amount of work would be done in WASM time to make kind of the defaults appropriate for GC being off, but exceptions being on by default, and that might be necessary. It may not be necessary, but no, I would not want to hold the implementation.
Yeah, I guess for context for folks, there was some discussion when we first did the EH based on GC around how small can you make GC. So we already allocate the heap lazily, only when the first exception object is actually created. But having it have very small defaults so that it's essentially equivalent to malloc in the exception object, I think is what we would want there.
Okay, and I'm happy to address this, but we are at time, so do we want to? I can do this.
You have
now,
20
but we can also-
seconds.
Okay. Oh God, I'm going to think for 10 of those 20 seconds. Set jump, long jump is based on exception handling. You can link that in via special flags. Just requires you to compile stuff. WASI SDK supports that natively. C++ exceptions will require a new build of WASI libc and WASI SDK, actually primarily WASI SDK. We do not have plans right now yet for what exactly we're going to do there in terms of when we will simply turn that on by default. New targets, new builds, a little unclear.
I think that was beautiful. And with that, the water cooler session is over. Please return to your desks for our next talk, Guest Languages by Joel Dice. I'm excited for this one. Joel, take it away.
All right. Hi, everybody. Just a sec here. Let's share the screen. Let's see. Move that out of the way. Can everybody see my slides?
We sure can.
Yes, and also very fun that you're like, I have a slide for this.
Oh yeah, oops, yeah. I was editing it at the last minute there. Let me go all the way back up here. Okay, this is where we're starting. Guest language is state of the art for WebAssembly in 2026, at least as far as I know. People feel free to chime in. Some of these ecosystems are much more familiar to me than others, but I'll give you a brain dump of what I know at this point. So I kind of split this up into two sections. The first one is about core WASM and component model features, which are either in progress or on the roadmap, which are of particular interest for implementing guest tool chains or extending the capabilities of guest tool chains, and not just the tool chains, but the ecosystem surrounding those tool chains, third-party libraries, database libraries, that sort of thing. So we'll look at that first, and then I'll go language by language in the second section to talk about where we're at with WASM support, and in particular kind of component model and WASI support in those languages. And then if we have time, we'll do a little Q&A as usual. Okay, so first features coming down the pike for core WASM and component model that are relevant here. We were just talking about this, exception handling. Thanks to Chris for the implementation. Sounds like we're not at tier 1 yet, but getting close, and could get close very quickly depending on priorities. This has already yielded dividends for some ecosystems. Set jump, long jump has been something that previously could only be achieved using an asyncify kind of CPS transform. Now we don't need to do that. And Ruby and MicroPython and Lua all are examples of languages and tools that can really benefit from that. The other big thing is C++ exception handling support, which is not officially part of WASI SDK yet, but we're getting close there. Alex created some experimental builds. I put the slide deck in Zulip, so you can click on that link to go grab that build if you're interested. And that's obviously important for the C++ ecosystem, but also the Python ecosystem. Cython, when you tell Cython to generate C++ code, it will unconditionally use exceptions. You can't turn that off. And so that means very popular packages like NumPy and Pandas are blocked essentially on this support. And so it's going to be very exciting to have that land. The other big thing coming down the pike for Core WASM is Promise integration implemented and stable in Chrome. My understanding is it's experimental in Firefox and in Node. And Safari, the Apple folks have very recently, they were pushing back on it, but it sounds like they're on board now. So that's coming. So all the major browsers should have support eventually. And just like with exception handling, this means for a lot of languages that we can ditch the CPS transform, no longer use asynchify and the performance and code bloat penalties that implies. And it also serves as a foundation for JCO implementation of component model concurrency, and then eventually, of course, browser native component model support. So super exciting. And we'll talk a little bit more about that in the context of stack switching as well. Just-in-time compilation, there is a proposal out there not implemented anywhere. I'm kind of interested in it. Whether it's actually relevant for serverless and embedded contexts is another question. I think it's still very interesting. Some languages are and tool chains, if it kind of comes to fruition, are going to be very interested in it. In the meantime, we don't need that. We do have Weevil, which is, you know, Futamura kind of projections, if you're into that lingo, partial evaluation, basically doing ahead of time loop unrolling, so to speak, of the interpreter loop. And Tomasz has recently revived its use in SpiderMonkey and has seen some great results there. So hopefully that lands soon. I would like to, at some point, experiment with it in componentized Pi, and you know, see it be utilized in other dynamic languages as well. I mentioned JSPI. Stack switching is kind of the core overall feature, you know, independent of JavaScript, that would really provide flexibility of managing multiple stacks and switching between them. Unfortunately, you know, the support in WASM time is still experimental. It's not widely implemented. It's not clear that it's going to be widely implemented anytime soon. The good news, though, is that we've anticipated and sort of polyfilled it in a sense with the design of component model concurrency, and that in combination with JSPI can get us basically where we need to go for a lot of languages with using today's runtimes. On the component model side, of course, you've already heard a lot about component model async functions, streams, and futures. The idea here is idiomatic, composable, polyglot concurrency. P2 had sort of a homegrown kind of concurrency model, but it wasn't composable. It was not necessarily idiomatic without a lot of boilerplate on top. And because of lack of composability, the polyglot aspect was kind of limited. On the host side, it's implemented in WASM time. JCo's getting close. Victor's doing some awesome work there. On the guest side, we've got binding generation support for all these languages with some underway. Let's see, cooperative multi-threading. Again, you know, if you saw Sai's presentation, lots of great work going on there. Should work in today's browsers via JSPI. I don't believe any work has started there on the JCO side, but the anticipation is that it should work. It's needed by pretty much every language. Even JavaScript has threads if you're using Node or workers in the browser. Experimental pthread support, again, Sai, you know, go see their presentation. It's awesome. Optional imports, you know, heard talk about that today already. I thought this was like a big project. It sounds like it is still a bit of a big project. Maybe it's more designed than I originally thought. It's certainly not implemented yet. It is needed pretty urgently to, I mean, I really wish we had this like 2 years ago, really, when we, oh, I misspelled adopting there. Wish we had it 2 years ago because already, for example, the C# folks would like to use this new exit with code function that was added to WASI CLI in a point release of WASI P2, but they're reluctant to do that because not every runtime necessarily supports it, and it's hard to express. You know, there's no way to express, okay, I can fall back to the old exit function. And it also, as Luke alluded to, makes targeting specific worlds easier so that you can fall back. If there's no file system available, component can still run, for example. Let's see, the guest C API, again, something that Luke has talked a lot about. It basically smooths the transition for especially for tool chains that already support WASI P1 and just treat it like a bag of imports. Treating WASI P2 and P3 the same way would definitely smooth adoption going forward. And so I think that's going to be a really important piece. And this has nothing to do with a core WASM or component model feature necessarily, but I do make a shout out to the WIT-dilib tool, which was recently added by Alex to WASM tools. And if you are interested in porting a new language, especially in particular dynamic language, interpreted language, to the component model, WIT-dilib makes that way easier. I've retargeted componentized Pi to use it. I'm working on doing the same thing for componentized JS. You can see Alex's Lua demo. Would love to see a componentized Ruby, for example, based on this, or any componentized scheme, whatever your favorite interpreted language is. So just an FYI there that exists and it's useful. Okay, so now that we've looked at some of the core WASM and component model stuff, let's dive into the survey of the ecosystem as it stands today and some of the to-dos. On the Python side, you can get WASI P2 and P3 support via componentized Pi. P2 can be accessed via the P1 to P2 adapter, and thus standard library stuff kind of works the way you would expect, doing sockets and so on. P3, you currently need to use generated bindings directly. There's no standard lib support that would follow from WASI libc and WASI SDK support for P3, which is in the pipe. We'll talk about that later. To-dos, there's actually, this is something I've been a community I've been involved with heavily, so I'm very familiar with some of the to-dos here. I mentioned C++ exception handling for Python, pthreads. Basically, the upstream CPython folks would prefer to skip WASI P2 and go straight to WASI P3 once cooperative multi-threading is available, and that will allow them to feel comfortable enabling, say, socket support because it's so heavily tied with threads in Python as an official feature. And that'll ungate some other things. Also for the scientific computing community, Fortran native extensions in Python are a big deal. This is something that I looked into a couple years ago, but haven't really updated on. So if somebody has some cycles to and is interested in this, it'd be interesting to see how Fortran and or Flang have come along in terms of WASM support. The other thing that Roman is working on these days is emulating the standard SSL module in terms of WASI TLS that would unlock a lot of third-party libraries such as database drivers. Let's see, JIT and or Weevil, something to start experimenting with. Official WASI P3 naming convention. This is basically if you want to publish WASI compatible wheels, which are the Python packaging unit on PyPI, for example, we're going to need an official naming convention, and Brett Cannon and I have been discussing that recently. Let's see. Go status. Okay, yeah, so Go made some real good progress recently. Historically, we've been focusing on TinyGo. That's had some pros and cons. We're kind of, at least we at Akamai have shifted our focus over to Big Go and have made some rapid progress. BindGen Go now supports it, including async support. If you do want to use P3, you have to use the generated bindings. I do have a proposal open on the Go project to add official upstream support so that you could use the standard library and get P3 support and full Go routine-based concurrency. And there's, if you take a look at that issue, you can see some examples. To-dos, the big thing right now is the Big Go compiler is based on a sort of a CPS transform to support panic, unwinding, and switching between Go routines. And if you look at the code that it generates, it's very understandable, but it's very big and very bloated, even for simple functions, because of the amount of bookkeeping that they have to do manually. And so switching over to stack switching and or component model concurrency is going to be a big win. I know that the folks on the Google Node team are interested in this already, and may be putting some resources behind it. And then we should be able to piggyback that with our P3 efficient P3 implementation, assuming that proposal is accepted. JavaScript, a lot of, if you check out Zulip, literally in the past few hours, there have been developments. Till's been doing some awesome work there. Tomash, others are eager to pitch in. But experimental P3 support is on the way. Experimental async support is something that I'm working on off and on. I've been kind of focusing on the Rust ecosystem lately, but hoping to come back to this using wit-dylib. Let's see, JavaScript to-dos. It sounds like Tomash has already been making some great progress on Weevil for performance. We want to finish the async and P3 stuff. We also want to find out what the right way to reuse certain parts of Servo without reusing all of Servo for winter CG support, things like fetch and whatnot. And part of that could be upstreaming sort of a modularization to Servo, potentially. .NET, I had been about a year or so ago very heavily involved in this. I haven't had a chance to kind of really stay connected lately, but we do have some good WASI P2 support in the Runtime Labs repo. It's not officially supported, but you can use the friendly interface to that is componentized.net or componentized-net. And then we have async and P3 support on its way. I'm sure Scott would appreciate some help with that. I've been trying to help as I can, but not been doing a great job of that. Apologies. But yeah, to-dos, as you might expect, finish that support. Wait for WASI SDK to get pthread support. That's going to be a huge boost for that ecosystem. Another open question is, given that we've been focusing primarily on ahead of time compilation, which is definitely what you want for best performance. How do you deal with reflection in that case? It can be done. It's just, it's very awkward. And maybe some sort of hybrid between interpreting and AOT might be the answer there. And then the other thing is, if you care about .NET, you might want to talk to the Microsoft folks and tell them you care about it, especially if you can put some money behind that in terms of, saying you're willing to kind of, I don't know, buy Azure credits and whatnot if this gets done, because the more they hear that, the more likely they'll take it seriously as an official target. Rust, Alex will know all the details here, but very quickly, we do have full WIT bindgen support. It was one of the first things we did in order to support the standard library with P3. We need WASI SDK, just like with a lot of these languages. Mio and Tokyo, after a lot of miscommunication, is landing now. Tokyo should land soon. That should unlock a big part of the async ecosystem in Rust. Our to-dos basically follow from the previous slide. I think another thing that would unlock a lot would be if we had a native TLS and or Rust TLS support for WASI TLS, in terms of just making existing libraries just work. Not sure exactly what that looks like, but I think it could be valuable. Okay, others which I'm less familiar with and will mainly direct you to other people. The C backend, this is all very relevant to WASI libc. You can use the bindings directly via bindgen C. Christoph is doing some great work on adding native P3 support to WASI libc, and that will complement size work on pthreads. C++, talk to Christoph, doing some great work there. Not sure exactly what the status is. Also don't know the status on Swift, except that people are apparently being paid to work on WASM support and they're taking the component model seriously, which is awesome. Ruby, we've got very solid P1 support, but there's been a bit of a lull there. Yuta Saito did some really interesting experimental work for component model support, but I think that has been sidelined as they are shifting their focus to Swift. Kotlin, Salim is on this call. Definitely talk to them about this. My understanding is it's mainly blocked on exception handling in GC, hence the questions just in the water cooler chat. My understanding is Scala is in a very similar boat. Java, boy, that's been a roller coaster. There was a very exciting announcement about native image support, AOT support via GraalVM. But then later in the year, Oracle basically said, Java on GraalVM just isn't going to be a thing anymore. And it's hard to imagine a Java solution that doesn't involve Oracle's cooperation in some way. So your guess is as good as mine what the future is there. Lua, take a look at Alex's demo. It's awesome. If you want to use Lua, it's pretty much, you could turn that into a production-ready system pretty quickly, I imagine. And Moonbit, great contributions there, chugging along with P2 and P3 and async support. So check that out if you're interested. And Q&A.
Well, Joel, you've already got one question in the chat from Alex. Can you speak more to the C++ exceptions requirement for Python? That part wasn't clear to him.
Yes. So let's see, Python's to-dos. Yeah. So Cython. So there's this thing called Cython in Python. And Cython is basically a way to write Python-like code that then gets compiled down into, or transpiled, if you will, to C or C++ code. And it's actually pretty readable C or C++ code. The C, if you're using the C backend, no problem. Don't need exceptions. You're good to go. If you're using the C++ backend, which is in fact what a lot of people use and what a lot of the popular packages like Pandas and NumPy use, you get exception handling and you can't turn that off. You can, if you're like really ambitious, go in and edit the generated C++ code to not use exceptions. I've done this. But that's just for an experiment, right? That's not going to fly long term. And so that's why we need exceptions. Yeah.
Sounds good. Thank you.
Yeah.
There's another question here. Well, there's a comment from Yash. Also read Rust support. The Rust project is now tracking the component work as a part of the 2026 roadmap. That's very exciting. And Chris asks, read Java. Do we have any info about Google's efforts to compile Java to WASM-GC in the browser? Is it a subset or dialect?
I wish I had an answer to that. I have not been keeping on top of the Java news. So yeah, if you've heard something about that, please put a link in Zulip and we'll all check it out together.
I believe it's definitely a subset that cuts off things, certainly things like reflection.
Yeah,
example.
Makes sense.
Yeah, Bailey says that Google is pretty into J2CL.
I mean, I looked at J2CL a couple years ago. I felt like it wasn't a good fit, but I can't confess I don't remember why. I felt like it was very JavaScript focused, but that could have changed since then.
It hasn't changed.
Okay.
It's very webby.
Yeah.
That pesky web.
It is super used though. I think it's what powers the Google suite, and it's emitting WASM-GC now, and it's I think used in production. So if I don't know enough about the details, if somebody were able to take that and kind of cleave off the JS bits and kind of use what they have, that's and WASM-GC support we would need, but that could be cool.
Yeah, I think the thing to emphasize and the thing that I learned back when I was doing the TVM-based experimentation was that it's one thing to be able to handle the full range of Java bytecode and make sure that the language is fully supported. It's quite another thing to support the whole ecosystem, which depends on the very large batteries included, J2RE or whatever they're calling it these days, the JRE standard library. And the key there is there was a time 10, 15 years ago where there were multiple competing implementations of the Java standard library. Now there, there was Harmony, and then Android adopted Harmony, and blah blah blah. Now there's exactly one with even there's exactly one that has decent coverage, which is the OpenJDK / Oracle JDK one, and everybody else uses that. Or so that would be the key, is like, can you actually pull in, ideally, a la carte, all the pieces that you need for your application and its dependencies.
Zalim says in the chat, in respect to Kotlin, we resumed our work on component model support. We have a prototype. We're working on a new modernized version, and we're aiming to ship it.
Sweet.
That's big news.
Yeah.
What other questions do y'all have for Joel? I know they're lurking out there. I can feel them in my WebAssembly bones.
Joel, are there places that you think that somebody that is a new contributor could come in and really help out?
Yeah, definitely in Python. I know folks at Fastly have reached out. Roman reached out. There's a lot to do that's very parallelizable. That could unlock a lot of stuff. Where's my Python slide? Yeah, I mean, maybe some of these can be, broken down into also parallelizable things. But yeah, anybody who wants to experiment with Fortran, the JIT side, I mean, the Weevil thing would be awesome, especially now that CPython does have a JIT. People are the cultural expectation may start shifting, which is, previously the attitude was Python is slow. If you need it to be fast, use a native extension written in C, etc. Now the expectations could start to shift to, actually you can do fast stuff in Python, in which case Weevil is going to, or equivalent, is going to be essential potentially. So yeah, there's a lot in Python. I'm sorry, was your question specifically about Python now, or did I just fixate on Python?
I like you fixating on Python because I care a lot about it, but okay. I guess it was more, if somebody wants to take on work, what venue, what forum do they ask about that, and try to figure out a good place to get started?
Yeah, I would say on the guest languages Zulip channel is probably the best place to jump in, and you'll get directed from there.
Speaking of which, on Zulip just now, Brett Cannon just posted a link to his to-do list with which has stuff people can help with right now on Python. So there are ways for all of you to get involved, and we'd love that. We got time for another question or two. There's so many languages out there. I'm certain there's more questions about them. Going once? Twice? Well, with that, you folks have all earned a 3-minute break. Oh, baby. So we'll meet back here in 3 minutes for our last session of the day, which will be Victor and Luke talking about Jquery and browsers. So
Oscar, is it okay if we water cooler?
It's more than okay if you water cooler. In fact, I'm going to kick off the water cooler. I'm on to my next seltzer, as you can all imagine.
Awesome.
This one is a guava berry. So we're getting into the advanced water, which I hope you all have gotten your own water beverages.
Stay hydrated.
Yeah, it really is a seltzer cooler. You're absolutely right. Luke, was that coffee at the seltzer cooler?
Could have been tea, but yeah, I think no, it's coffee. So one thing I just wanted to throw out there, I don't know if other people have had experience with this, but I've been having great success with using component composition when certain features aren't working, right? Like, I have issues in one language, let's say Go, and what I can do now really easily with this new LLM world is generate in Rust. Just about any time I run into a problem, it's already working really well in the Rust toolchain and ecosystem. I just, do a port with my friend, the LLM, and it's been working great. And by composing them, I'm able to usually get, best of both worlds. Existing toolchain, existing code that hasn't been ported, plus the new thing that I'm bringing over. So it's kind of the strangler pattern applied to components, which is pretty neat.
And Bailey, you'll have to share your models with me because last time I tried using AI, it hallucinated instructions. So let me know what you're using.
I mean, I'm on Opus 4.6, which I think just about everybody's on right now.
Don't that cost money?
Aren't you like a director?
No, I'm not. You know what? I'm not, Bailey. I can't afford these tokens, okay?
Yes, it costs money.
That's rough. Can't spend money on that. I gotta spend money on WebAssembly stuff.
I think you should talk to Ralph.
All right. Ralph he is the guy I go to when I need money. Yeah, I do got seltzer to buy. You're absolutely right, Joel. Can't spending this on tokens. I need water. All right, folks, we only got like 30 seconds, so you gotta get your water cooler in like can. Oh, actually, time's up. Joke's on you all. And with that, we're gonna move on to our last talk of the day, Jco and browsers, with Victor and Luke. Take it away. All right, thank you. Thanks, Oscar. So I'm gonna go ahead and share my screen here. Here we go. Okay. Hopefully everyone can see that just fine.
Looks good.
Okay, great. So yeah, this talk, or at least the first part of it, is going to be about Jco and browsers. We're going to start with just the Jco bit before Luke comes on and talks more about the browser bit, which he's gone over a little bit of actually already, very very early in the day today. So for people who are maybe not familiar, I think many people on the call are, but just for those who aren't, this is a quick overview of the sort of WASM ecosystem for JavaScript. So it starts sort of, I've gone sort of lowest level first. So Starling Monkey here is essentially the wrapper around Spider Monkey that compiles to support guest components, right, that are written in JavaScript. So for maybe those who really aren't familiar, SpiderMonkey is a JavaScript engine, one that powers Firefox, and that code base compiles to WASM, but obviously doesn't necessarily implement everything that is needed for the component model and various other features. So Starling Monkey is a project that makes that possible. SpiderMonkey obviously is written in C++, and so Starling Monkey sort of wraps that and makes that available to the next sort of step in the toolchain, which is componentized JS. And componentized JS's job is to essentially take JavaScript code, and it offers a sort of user-friendly interface to taking some JavaScript code and adding it, or essentially loading it into Starling Monkey and making a JavaScript component out of that, single ES module. And just as a note, things are ES modules, so we're very ES module focused here. There's no like Kotlin.js or anything like that. One of the projects that's kind of important but less discussed is the SpiderMonkey embedding splicer, which essentially manipulates the component, the WebAssembly component that you'd normally have with the embedded Starling Monkey engine, and adds or removes imports and exports as necessary, and facilitates the actual communication that occurs when you call an export or call an import. That happens to be written in Rust, so componentized JS is a bit of a mashup of Rust code and JS code. Then on top of that sort of middle layer is Jco, which actually calls down to componentized JS to do its componentization. So if you call Jco componentize, it actually just calls straight through to componentized JS. And there's a bevy of sort of supporting projects here that try to make it easier to work with componentizing, or basically components that have been created, and importantly, to transpile components so that they can run in JavaScript environments that are not, and sort of use JavaScript environments as a WebAssembly host with support for the component model. So this means that you can take a component that was written in any language, Rust, Go, JavaScript, of course, and run it in any environment that has a engine that supports WebAssembly, a JavaScript engine. So that means browsers, and that means Node.js, for example. A quick run through the projects here. Jaco is obviously the top level CLI project. That it's a Node.js project, but uses lots of different parts. So in this case, it actually uses some Rust code as well to access a lot of the upstream WebAssembly like tooling. And there is Jaco Stud, which is a sort of amalgamation of useful utilities for when you're writing JS guest components. So this means, or writing for JS guests. So this means writing JavaScript components. It does useful things like adding a simple interface for like making web servers, for example. Jaco Transpile is the key to doing the host into turning a JS component or any other component written in any other language into something that could be run on Node.js or in the browser. Jaco Transpile is basically a way to take a component, and we'll talk about this a little bit more later, essentially break it down into WebAssembly that most engines support. So this would be sort of core WebAssembly, and then wire up the requirements of the component model such that you can run with just JavaScript and the core WebAssembly. JS Component BindGen is a crate that is written in Rust and helps to make basically Jaco Transpile possible. It includes a lot of it makes heavy use of the upstream WebAssembly tooling that's been developed by a lot of the people on this call, and makes it easy to generate essentially the binding and the glue code that makes a WebAssembly component run as essentially core WASM in many various JS runtimes. Another sort of small tool that is not very well known is actually we have a small chunk essentially of WASM tools componentized in Jaco. This is something we've actually wanted to spread and sort of componentize more parts of WASM tools component, but right now I think this is the one place where this lives. And the last two are actually useful for components that are written in JavaScript, and they're actually post sort of componentization when a component is being run. So they are shims for the WASI interfaces that are present in Preview 2 and upcoming Preview 3. So this is a quick overview, again, of just how you take JavaScript and turn it into a component in the ecosystem as it stands today, right? So essentially, we build SpiderMonkey into a WebAssembly binary with P2 bindings built in. And again, that happens via StarlingMonkey. So StarlingMonkey is SpiderMonkey and more. We take essentially your input JavaScript and we build it into the StarlingMonkey WASM and essentially bundle it in there. And componentized JS splices interfaces, and in this case, I mean WIT interfaces. In the binary, we run a tool called Wiser to initialize and snapshot the WebAssembly binary. And then we pass, obviously, when you want to run the component to a runtime, right? And obviously, this runtime doesn't have to be Jaco Transpile. It can be WASM time. It can be any sort of component model compliant runtime. In this case, and in browsers, it's V8 or anything else, and in on servers, it's quite often Node.js. So one of the things that's changing now is we're adding P3 support onto various parts of the ecosystem. So obviously, one of the things I'm working on is P3 host binding. So this is basically integration of P3 and sort of new async functionality and interfaces into the host, right? And when I say host here, I mean J-code transpile. So you can think of the output of J-code transpile as a sort of generated host, right? That runs on, let's say, V8 below, or any sort of WebAssembly supporting, or core WebAssembly supporting JavaScript runtime, and glue code. So that's sort of those two things together come to build a host. So I'm working on the P3 host bindings for that. Till has started working on Rust bindings, and essentially a sort of harness around Starling Monkey that makes it, first of all, a lot easier to implement. Well, I say easier and safer to implement features, and along with doing that, implement features in Rust. And along with doing that, one of the things that sort of falls out of that is that Rust right now has great support for P3 on the guest side. So that makes, obviously, creating P3 a lot easier. Joel, who just gave his talk a little bit earlier, is working on componentized JS, and notably sort of rewriting it to use with dylib, which was also mentioned earlier. And this is, I think underappreciated, because it's going to get rid of a sort of circular dependency that's actually always existed, which is that JS component bindgen is actually used in componentized JS, but it's transpiled. So it's a little bit circular there, and it can be really confusing for people who are new to the sort of setup. It's a little finicky sometimes. So thanks, Joel, for that. Along with that, we've got work ongoing, and a lot of this is exploratory but extremely promising for alternative runtimes like componentized QJS. So this is QuickJS, specifically QuickJS New Generation, which is the sort of community project that sprung up around Fabrice Bellard's original QuickJS project. And so that exploration is sort of a combination of with dylib and this QuickJS New Generation project, to see what it would look like to build a componentized that is not dependent on Starling Monkey in particular, but uses a different sort of JavaScript engine on the guest side, right? So on the component side. I think this is really nice because it represents like a sort of point in the, let's say, the trade-off space between size and like how many features are supported, because obviously QuickJS has fewer features but also generates smaller binaries than something like Starling Monkey with Spider Monkey underneath it. And along with this, I've sort of covered it before. Till is working on essentially P3 guest bindings. So one of the things that, moving on from what you can sort of do and with the guests and how pieces of P3 are progressing, if we talk quickly about how a component runs in J-code transpile, I've covered this a little bit before, but basically it performs, or J-code transpile performs an unbundle of your component. So I call it, I have Wasm tools unbundle here, written because that's an actual command you can run with Wasm tools, the sort of upstream tooling, to take a component, break it apart into core Wasms, and those core Wasms will have imports and exports that are required to implement the component model. And the host has to obviously supply those imports and exports. In general, these steps sort of happen, imports need to be wired somewhere. Generally, for a host like J-code transpile, the kind of sort of host and glue code that it generates, you need to walk the sort of Wasm instructions that are called from the core, inside the core Wasm, and do something, right? Like, for example, if a specific instruction or a canonical, essentially instruction is called that would do something like, let's say, a task, return, or like something that would perform, like do something with a resource, for example, you would need to handle that in your host code. And that's what J-code transpile does, right? It adds code and sort of glue code that does the right thing when a certain Wasm or a component model intrinsic, let's say, is called. So it does these things. It generates this glue code. It outputs the core WASMs that were sort of unbundled. And then it adds stuff like support for GSPI for places where async behavior should occur, or whether the host has async behavior to expose to the component. This is actually kind of also underappreciated because there are a whole bunch of places where it makes a lot more sense to provide an async host implementation to a component, but obviously components need to have that wrapped before they can call that import, and GSPI is one way to do that. So thanks to Calvin, who also implemented this last year, if I remember correctly. So what's changing with P3 components? So that's all of that I've talked about up until now is what Jaco does or does for P2. But in P3, how this changes is that we basically have more support for more intrinsics and more pieces of the component model that are required for P3. This generally plays out in like supporting new imports and supporting new kinds of exports that essentially unbundled components use. But it also extends to new kinds of intrinsics and instructions that are used in the WASM, in the sort of core WASMs that are being that are defined or that are essentially unbundled. So this means that code that basically supports the glue code that is generated here needs to support doing everything a P3 compliant host would do, just like we had to for a P2 host. And so this means new kinds of sort of lifting and lower mechanisms and new kinds of sort of intrinsics and state to manage that basically the host has to manage or has to sort of manage in the same way as other component model P3 compliant hosts. In this case, how GSPI is used is becomes a little bit different and slightly more complicated, because as async imports are now possible, one of the things that's happened a lot is needing to essentially thread and make sure that certain not only host imports but also some component exports are properly using GSPI, and sort of you can have a sort of call chain that makes more than you would think necessary for essentially invoking GSPI and wrapping component exports and host imports. So a quick look at sort of what's done and what's left. I think right after this, I'll show you a bit of the code and what this ends up looking like. But up until now, a lot of the work has been on semantics and trying to get the Jaco implementation of the host as close to what is already working and working quite well, thanks to Joel and Alex's and Roman's hard work, and getting sort of Jaco to be close to doing or working in a similar fashion to Wasm Time, and the P3 support that has landed in Wasm Time via the guests and also the host is pretty solid. So we try to follow that and also follow the spec independently to implement all the sort of features. So this is kind of a list of features of the component model in general, but we've gone through a lot of the sort of semantics around async tasks and subtasks, waitables, back pressure, etc. And right now I'm working mostly on support for streams. So this is, right now I'm sort of doing this sort of long tail of making sure that values you send through streams all get sent properly, lift and load properly, and there aren't any surprises there. And of course, I'm stopping short of writing a fuzzer, because I think that's clearly what we want here is sort of property testing, and this is what Wasm Time actually does. Very solid implementation there. But to avoid being any more late than I already am, we're gonna just we've just got a large list of functions that just we just try a bunch of different combinations. The fuzz work is likely far in the future. And after this, what we have left is futures, which are basically streams but simpler, with slightly different caveats, and P3 shim integration. Now, the P3 shim work is actually at one level already done, and initial implementation is there. Thanks to Tomasz for working on that. And we've written it in such a way that it should be simple to integrate, but it is just one of those things that we have to actually integrate it and sort of put the two pieces together once the sort of base level of sort of streams and features is done. And one note on why we have to do that is that P3 interfaces, so like interfaces to things like standard out, standard in, that are provided by WASI, are written in terms of P3 primitives, like streams, let's say, or features. And so there's while much of the shims stay the same, some of them will obviously have to change. So there's a little bit of integration work there. And in the future, at some point, threads should and will need to be implemented in the Jcode transpile or JS host. Right now, we essentially pretend like we have one thread, essentially, and so tasks are not able to spawn new threads. And like if you, for example, if a component tries to call the intrinsics that create, start a new thread or spawn a new thread, you just basically get a error thrown, right? So you just get a trap. And here's a little bit of what would be nice to have in the sort of far future. There's a lot of implementation polish that needs to be done. Part of the work on P3 was just sort of reorganizing and getting the code base into a shape that makes it easier for other people to contribute, which I think has gone well so far. Debugging, I think, has also been a sore point for some users and also myself while working on it, because there's multiple layers, right? You can have errors that happen at the starling monkey layer, slightly less at the componentized layer, but that's always possible. Of course, if you're dealing with a JS guest, like a JS component, and then you have issues that can happen at the host level, right? So you have all these different levels, and of course, when you're actually executing the component, knowing what's happening and which, like for example, which intrinsics are being called, or which, like, at what point you've entered an import versus left it, etc., can be hard to debug. So one of the things that's being a big part of this that I've been focusing on is this a new Jcode debug flag, which sort of gives you essentially not quite a trace, but a sort of just logs essentially a lot of the internals of the Jcode host as it runs. So it makes it very easy to debug. And of course, the usual, improving documentation and getting to better testing. So I wanted to jump in a little bit to something a bit more practical and show what the code looks like, right? So, in particular, what sort of a simple P3 interaction looks like. So if we have this simple, and this is taken from a test inside the repository, so it is out there already and merged at this point, though there are more tests to write. But so if we have a win interface that looks like this, and you just take something simple, like you want to, this test is written to take basically a list of values, a list of U32s, and return a stream of those very same U32s, right? So basically trivial. With a wit like this, so importantly, you've got the stream of U32s coming out of there. And so in this case, in the Jcode's case, we use Rust guest code for this because obviously we can't use JS guest code just yet. Really, the important part is down at the bottom. So you see the implementation for that get stream U32 function that was exposed by the world in the previous slide. You can sort of ignore a lot of the syntax here, but in particular, we basically just take the list of vals or U32s in the vector, and we just write them all back, right, after from an async task that we spawn. So what does that look like when you try and use it from a Jcode transpiled component? So code here, there's this code is a bit sparse and sort of, I've deleted some stuff to make it clear, but most examples will look something like this. After you run Jcode transpile, you get a folder with, as I've mentioned earlier, unbundled components. So essentially WASM core modules and glue code, right? So the entry point of that glue code, you can import as an ES module from your code that's looking to use the component. You can also specify the WASI shim. So in this case, we actually add in a WASI Preview 2 shim. In the future, this is going to look like a WASI P3 shim, but you can actually modify this import object that's generated to look like whatever you want, right? So ideally, you can have a shim that has both P2 and P3 interfaces, and anything else you need for running different components that might be built against different, essentially targeting different versions. And so once you have your module and you've called this instantiate function, you have an instance, and on that instance is exposed the interfaces and functions that you wrote into the world, or that you built into the component. So here we call that sort of get stream u32 function, and we basically just await on the stream that we get out of it, right? So we get, and this is also sort of compatible with async iterator as it exists in JS as well, but we do it sort of manually here, and we sort of await the values, and you do end up getting obviously the values that are listed there. So it looks quite I would say normal and kind of idiomatic for JS, and the one way that isn't implemented just yet, but will make it even more sort of clear and easy to use from the JS standpoint, is making sure we return sort of web platform and basically like sort of WinterTC relevant objects. So just like the built-in streams and readable stream and writable stream and stuff like that, so that it is much easier to use and sort of, let's say, familiar for people who come from a strictly JS background. So when can you use it? You can use it right now, but you're probably going to run into some bugs because there's still bugs, mostly again with just all the sort of combinations of things you can send in a stream, which is what I'm working on right now. And of course, if you try to use the future, they're not quite ready yet. So those are some of the places you'd mostly run into issues. At this point, sort of running tasks and running async imports versus exports is quite stable at this point. But of course, that's not all of it. We still need a lot of the sort of interesting usage of P3 host is going to be centered around obviously streams and futures. So releases to JCO are happening as this support improves. And so right now, version 1.17.0 is out. And 1.18 is going to likely be out this week. And that would include improvements to stream support, and hopefully, if we can get it, futures this week. So we'll see if we can hit this milestone. And I noted this earlier, but another word about the P3 shims. So Tomasz worked on this. The test suite is independent, and this is a link for anyone who's downloaded the slides. You can click through and see them. And they should be current on the 0.30 interfaces, because I think they were updated relatively recently, and I don't think there have been any significant changes since. And moving into the browser talk, this sort of second side of this, browser support is actually still experimental in JCO, mostly due to missing P2 shims that never essentially got implemented. And at this point, browser support for P3 shims are deferred to sort of post 0.30, lightly at this point, but high priority after sort of the Node.js shims that exist right now stabilize. So I'm sure people who love the browser are probably not very happy about browser support still being experimental, despite JCode being around for a very long time. And people have actually been stepping in from the community to help us implement some of the missing pieces. Of course, there's not a ton of, it's not unusable, right? But it's just not a host target that is currently well supported. For example, HTTP fetch, or basically outgoing HTTP or HTTP sort of outgoing handler, was not well supported, and that's obviously something you'd want to do from inside the browser. So thanks to this GitHub user Dan Bopes, who stepped in to add this implementation. And so this is one of the places that if you are watching and you love JavaScript and you like WebAssembly, you want to get your hands dirty, there are lots of sort of low-hanging fruit left to fill in on both P2 and P3 browser shims. And this would directly affect and help anyone who's trying to run WebAssembly components in the browser with using the browser as a host. And that's it. So I'm happy to take any questions now. Thanks to all the contributors. There are way too many people to name, really difficult, but just across the ecosystem, a lot of upstream crates that we depend on, whether it's like Starling Monkey, Jaco, or Componentized.js. It's really a team effort, and so it's great to work on this with everybody.
Thanks so much, Victor. We got time for about one question, and so we'll see who the lucky person is who gets to ask it.
And then we'll throw it to Luke to talk about the web, or maybe we
might have to push some of that to tomorrow. So got to be respectful of people's time.
I didn't have much to say other than this is very important work. Great job, Victor. This is so strategically important for, the browser is so important to WASM, and Jaco's so important for the browser story for reasons I said at the beginning. So great job. Your work here had to span concurrency, which is already hard, Rust and JS and new features and make a bunch of things work together. So thank you.
Yes, this is all very, very, very exciting. And I still stand by all of this working really well in the browser is going to be the thing that makes it work really well everywhere. So fantastic work. And then Victor, if I can get you to stop sharing for a moment. There we go. So y'all can see this beautiful slide that Bailey made. It can't go to waste. So yeah, on behalf of the Bytecode Alliance Technical Steering Committee and the Bytecode Alliance Board, I just want to thank all of our presenters today for taking a ton of time to put these presentations together and to come and present them today. And also thank you to everyone who is attending and who watched here on Zoom or watched on the YouTube stream. We really appreciate all of you. But the fun is not over. Join us back tomorrow at 8 a.m. Pacific to continue the journey through what's going on with the component model and WASI. So with that, see you folks tomorrow. Take care, everybody.